distractions with your fantasy. I feel so hard, that's why you followed me. And while you're watching, girl, you're gonna see there's so much more than what you've done to me. It's escalated, what's your policy? I'm watching now, I see you don't agree.
No, I'm never gonna let you get away. Never gonna let you leave me. Never gonna let you get away from me. It's what I feel for you, I can't hide. Can't control the way I feel inside. Never gonna let you get away from me.
A highly sophisticated business computer, and to use it, all you have to do is learn this. This is Macintosh from Apple, also a highly sophisticated business computer, and to use it, all you have to do is learn this. Now, you decide which one is more sophisticated. Macintosh, the computer for the rest of us.
Hello, everyone out there. I have the air conditioner going on because right now in Jersey City it's 80 degrees out, and also it's not Crypto Baron. So let me. I always forget to turn off that logo. There we go. Now we're just the normal live feed. I was supposed to start way earlier than this. Everything's been going crazy in my life, hence why, like, also give it to Apple to like start a talk at like a live stream at like 1 p.m. and 4 p.m. when everyone's working instead of like your normal hours here. So now that I make sure that the audio is working, hi, welcome to this. Well, my portion is going to be short, but then we're going to kind of air a ton of videos. If you want to know who I am in this crazy room with the crazy hair, I am Side Pocket. I'm one of the two co-founders of DCG 201. I'm supposed to update Instagram. It's craziness today. But I'm one of the two co-founders of DCG 201. We are a computer hacker collective group that's located in New Jersey, hence the 201 area code, and more accurately in Jersey City, New Jersey, Jersey City, New Jersey, for those who don't get the accent. We normally meet once every month. It's been a really rocky year for that. We usually meet every third Friday of the month, but things have been crazy. But we're now going back to some form of normalcy. We're going to be updating about that tonight and tomorrow. And if you want to know more about us, just because I'm trying to get the intro stuff out of the way, here is a direct link to our blog, which is on Medium, because we do have a website, which I will also share in the chat right now. However, again, we're still, just because we've been so busy here behind the scenes with personal life stuff, the certs are off. We know that. We're trying to get them fixed in the next couple of days. I know I've been saying that for like 3 weeks now, but just bear with me. I'm on a time limit in real life. Everything's kind of going crazy right now. But I just also post a link to the website, but better would be our Medium blog currently. If you want to interact with us on social media and get last minute stream announcements like this, I just put a link tree in the chat. Our most common social live streams are our Twitter at DEFCON21NJ, as well as DEFCON201 on Instagram. We're also DEFCON201 on most things, such as the Mastodon instance, hostux.social, on GitHub, on Minds.com, Facebook, all of that. Also, if you like the content that you see today, you can, for free, follow, like, share, and subscribe to us on our main three platforms, Twitch, DLive, and YouTube. Get this going. Loud phone. Turning that down. There we go. I know I'm saying I'm a lot. It's a crazy day, by the way. What was I getting to? Yeah, you can follow us. We get little prompts when you follow us, and if I'm on cam, because I'm going to be going away from cam in a moment, we kind of like cheer you on. However, you can subscribe to us anytime. You get notifications when you do so, and subscribing us really helps us out. And particularly if you're on YouTube, if you can click that bell and turn on all notifications, that will make sure every notification when we go live stream, we're going to be doing a lot of live streaming this week, we'll make sure to get to you, because YouTube fucking sucks. And we're also live streaming on multiple other platforms, including Diode.zone, which is a PeerTube instance, which we absolutely love, as well as on NVIDIA through Tor for the super secret hacker stuff. If you are watching us on Facebook, though, first of all, our condolences. Second of all, you can chat with us, but you kind of need to hack Facebook in order to get it to work. I just put the link for that in the chat in order to chat with us. And very last but not least, we're trying to use this more. We mainly use it for CTF, which is why you're going to see the pound CTF sign. But if you do want to chat with us until we get our IRC sorted out later this month, here's a link directly to our Discord. So, what are we live streaming today? First of all, I like an interactive chat. If you guys want to talk with me, that's fine. I'm going to be busy as well, so I might not be able to interact too much. But if you also are watching and lurking, just watch and lurk. Well, basically, Apple, as I said, in its infinite wisdom, decided to, while everyone was fucking working, to do a live stream about their big convention, which is the Worldwide Developers Conference. Which I always abbreviate that to WWDC, which drives me crazy because I always read WWDC as WWJD, aka the What Would Jesus Do thing. So I always keep asking, hey, Yeah, have you seen what Apple asked what would Jesus do at their new convention because they don't know how to name things? Google has a real name, Google I/O. Even fucking Microsoft has Microsoft Build Conference. You know, it's a boring name, but it's a name. Apple just wants to confuse all search engines, but they decided to live stream. I saw parts of the keynote and the summary. We're going to get into probably the one biggest piece of news, but what we're going to be doing now is that for at least half an hour or so, we're going to be watching and it should still be going on, what's called the State of the Dev or whatever it's called. What the heck is the thing called again? The State of the Apple State of the Union, like they're a country or something, which goes into more detail about how their various technologies and APIs work. We're going to kind of catch the end of that. And then afterwards, originally it was supposed to be from 4 to 5, but craziness today. So it's probably going to be closer to like 5:15, maybe 5:30. We're going to fill up time until 4 p.m. by going over a bunch of Apple hacking stuff. Thank you, Sertman, for just getting to us on Discord. Again, I'm having a hard time talking. I'm going to be away for those pre-recorded videos, but it's going to be a recap of all the DEF CON 26 Apple hacking talks, as well as the amazing Objective-C convention called Objective by the Sea that happened earlier this year and all of their crazy exploits. So let's go into desktop mode.
Hey,
And
what's
let's
up,
look at
DEF
the
CON
big quick
7
news
I'm
today.
super humbled and
So the
excited to
big
be
news
here,
today
and I'll be
is
talking
that
about
Apple finally
basically giving a
unveiled
perspective
and
of what red
announced. Oh
teaming looks
crap!
like
Sorry, hold
in a
on.
macOS
This
environment
auto
here.
started for no reason. That's a preview of what's coming up later. But here we go. So the big news that happened today is that Apple finally, after long talks, and I'm getting a phone call right now that I have to skip in a second, is revealing the M2 chip, and they're revealing, I think the first hardware they announced it for is their new MacBook Air and MacBook Pro. Let's see the press release for this right here. Apple today announced the M2 beginning the next generation Apple Silicon, designed specifically for the Mac. Built using second generation 5 nanometer technology, M2 takes the industry leading. Let me zoom in a bit more here. Sorry about that. M2 takes the industry-leading performance per wattage of the M1 even further with an 18% faster CPU, a 35% more powerful GPU, and a 40% faster neural engine, which is their weird kind of processing, like trying to take the overhead off. Note that these are, by the way, Apple's metrics for percentages. These are have not been yet audited by an outside source. A lot of hackers are going to get to that. In fact, basically, as soon as these new MacBook Airs and MacBook Pros go on sale, it's going to be an arms race to see if we can bust the M2 as fast or even faster than the M1. And we'll find out new details when hackers get to that and people like iFixit and other right to repair folks. It also delivers 50% more memory bandwidth compared to the M1 and up to 24 gigabytes of fast unified memory. It's really interesting to see Apple really going for unified memory stuff. M2 brings all of this plus new custom technologies, great efficiency to the MacBook Air and updating 13-inch MacBook Pros. This is kind of a like a map of that's the M1 chip on the left. The M2 chip on the right seems to be slightly bigger and has a lot more busyness going on. You can kind of the M1. I'm already looking at it, and from my limited knowledge of chipsets, you can kind of see that things are. You can kind of see where certain parts of the die are in certain places, but everything seems to all over the place. The M2, I can more see where like certain sections of where the chip is processing what on here, so that's kind of neat. System on chip design, 5 nanometer technology and 20 billion transistors, and delivers 100 GBSs of unified memory bandwidth, which is way more than the M1. Let's see here, is there anything else? Let's see, there's 18% according to Apple's own metrics, remember, not independently audited, 18% CPU performance versus power over the M1 for the M2. 35% GPU, which is kind of funny because most Apple stuff, the GPU is used for like video editing and shit like that. Even though Apple's been trying to do things with Apple Arcade and stuff, and there's been rumored for video game things, along with the rumored Apple Car and Apple VR headset, which they have not announced today, as far as my knowledge. That's usually for like mass bandwidth of live streaming, video editing, image editing, music editing. It's never for like video games and maybe crypto mining, but I haven't really heard of good uses for Macs because it's really easy to get the cheaper um, GPUs that PC gamers use and annoy the crap out of the market by crashing it. Let's see. Here's some custom technologies. Neural Engine can deliver 5.8 trillion operations per second. Media engine includes a higher bandwidth video decoder supporting 8K, H.264 and Head C video. ProRes video engine enables playback of multiple streams of both 4K and 8K video. I'm going to assume that simultaneously, but as worded. Secure Enclave, which is another thing hackers are going to have to break again, is apparently a new security feature. A lot of the keynote, they kept repeating security. You're going to see that, by the way, a hacker's perspective, you're going to see that with a lot of technology companies. And Microsoft's going to keep promoting how secure their stuff is, Google and everything. And even if it's done in earnest, it's been muddying the waters so that privacy and security are now snake oil terms, like the same way like cryptocurrency has turned into, instead of actual proper security, which is why I recommend things like privacyguides.org to look up actual security for Mac stuff and Linux stuff, and definitely not Windows stuff, as opposed to listening directly from corporations. And there's a new image signal processor to deliver better noise reduction. Mac OS has been designed for Apple Silicon. The M2, let's see, Mac computers. The Mac OS Ventra coming this fall, so that's going to be the new OS. We'll take advantage of the M2 bringing new features. By the way, if you hear humming in the background, that's the air conditioner because it's fucking hot in here. For Stage Manager and powerful new capabilities. And as far as I can see, that seems to be most of it, including their supposed carbon neutral plans, because our planet is failing. The last thing I do want to bring up here, because I was going to bring this up earlier. I'm just going to search for it. Is if you are on Twitch right now, there's a little widget for our GitHub. We've pinned a certain bunch of these. If you want to know, and you're going to see a bunch of these talks later, a really good look at like actual Mac OS security tools, the latest in malware and malware prevention for Mac, the latest for exploits and the documentation of those bug bounties. You can go to the wonderful folks at Objective-C. It's a joke on the programming language. It's Objective-SEE, not Objective-C like the programming language, even though that's what it was based off of. And I'm going to put their link in chat. We're going to see a ton of videos by Patrick Wardle and friends from this website later on, but I thought I would just shout them out. And if you are on our GitHub, or if you're looking at our GitHub widget on our Twitch, you will be able to see some of the most recommended like privacy and security tools that they offer that are completely open source that every Mac user should have. So with that out of the way, hopefully the State of the Union address for Mac is still going on. We're going to attempt to watch this thing and hope the stream doesn't screw up and crash. And we're going to be commenting on it. I think I'm going to do that because it's super late now for at least half an hour. Let's see, from State of the Union. There's an overview. Because we were literally just watching this live. If not, then we'll just go straight to the videos. Let's see here. Because I was literally just testing this when we were watching this live. Crap, did we miss the whole thing because of my... This is why I should have taken off of work today. Because that's why I'm doing... If I didn't have work, we would have started directly at 4. But, you know, you need to make money somehow. So, let's see here. I'm going to see if I can find it. I wish they'd have it on YouTube. Let's see. Videos. Inclusion. Seems to be like all the stuff that they talked about as individual videos. So I think instead of just one giant presentation, it's now broken up into all these different tiny videos, which sucks. Let's see. God damn it. State of the Union. Okay, so this is the video. Let's see. Overview. That's why I was just on. Why isn't this loading? Hang on. I'm going to figure this out. We were literally just watching it earlier. Alright, as much as this drives me crazy, I'm going to go search for the platform Save the Union. Hopefully, maybe there's a YouTube archive of this. Let's go to Apple's. Again, I apologize. There was literally one video that like hung us up earlier that prevented us from starting at like 4:30. Let's see. Otherwise, I'm going to be mad. Let's see. That just happened. Driving me freaking crazy. Let's see if there's an archive on here that we can look up. Let's see. I'm so frustrated right now. I'm going to quickly click into this and we're going to see if the State of the Union might have actually been folded into the conference itself. I'm going to check that. No, it hasn't. God damn it. So did we miss that? Ah, this is pissing me off. A deeper dive. God damn it. I tried to do one good thing for our live stream channel. Everything goes up in smoke. Worst comes to worst, we can watch some of the individual videos, and then I will put on. I will then put on the videos where I will be off screen, and you can learn some Apple hacking. But this is driving me crazy. Because I was literally just making sure, like, okay, it was running, and then I had to fix something else, and then now I'm on here without that. Let's see. All right, I think what we're going to have to do, sadly, is we're going to have to, like, look at some of the individual videos, which I guess is a blessing in disguise, because that will allow us to, that will, I think, allow us to, like, cherry pick what we want to look at. I just want to make sure that I haven't gone, like, completely batshit crazy. Platform State of the Union. Yeah, unfortunately, I think we're now going to have to, I think it's just, we're going to have to probably just cherry pick the videos, so let's see. Let's see, what do we want to look at here? Because there's many different topics, many different videos. We're not going to watch them all, obviously, but let's see. Let's look at what's new in web accessibility. Provided it, or is it just, nothing's going to load? Or is this an older video? Oh, older video, hang on. Ah! Why are you all driving me crazy? No! See, I think what happened, let's see, is, what's today's date? Yeah, these I think are all just like the future tutorial stuff. All right, let's use a general search engine here. See if we can find some gold here. I don't know why they don't put this on YouTube. Let's see. Let's specify the year. I am going absolutely apeshit right now because I was so excited to watch this with everyone. But again, I don't know why. See, because Apple likes to be their own like special little head case. So of course they aired this. Like they couldn't just air this at like 5 p.m. Pacific time, which would have made it like 8 p.m. our time, like sane people do. Instead, they had to do it like right when everyone, including myself, was at work. That's when they decided to do all of this. So now we're stuck here without a live stream. Oh, does this one work? Okay, so I think we found the State of the Union video. Let me just see how it looks in widescreen mode here. Because I just found it for ASL, and even though it would be nice to have ASL, I don't know if anyone's watching that actually is using it. Let's see, related videos. Maybe I can. Please let. Oh, thank God. Okay, so this is the normal one. All right, so now I found it. I hacked Apple to find the video of it. So we're gonna watch this, and then we're gonna run through all the videos because I have a bunch of other stuff to do. So, and if I disappear at one point, like for like 10 minutes or so, it's because I'm running around doing some other things. But let's watch what we missed here. I wish we could see it live with all of you, but at least we get to prop this up here. So away we go. Keep forgetting it's not Crypto Baron.
Welcome to the WWDC 2021 Platform State of the Union. WWDC is a time when we come together as a developer
Why are they
community
saying
to look at what the
dub-dub?
near future holds.
What's
for our
with
platform.
dub? That sounds like a children's toy.
On how the work you did helped all of us to get through this past year. Your apps and your creativity have enabled people to find new ways.
That's perfectly fine. Just keep lurking and keep learning.
Extraordinary circumstances. There are so many great examples of developers making a difference, and we know there's much more we can do to help you make the world
While she
better.
blabs, I'm going to go get a drink. I'll be right back.
So this year, we're delivering tools, technologies, and APIs designed to help you accomplish more. And we'll be talking today about 3 big areas where we're making that happen. First, we'll talk about the things that help you to build great apps: Xcode and Xcode Cloud, Swift, and our UI frameworks. Then, we'll look at how Apple technologies can help you build apps that make it possible, with augmented reality and our graphics technologies, for users to see the world in new ways. Finally, with new features like Focus, the Screen Time API, widgets, and Share Play, we'll see ways in which the apps you build can help users better connect with each other and prioritize what's most important to them. Let's start with developing apps. To tell you more, here are Allison, Rhonda, and Andrew.
Developing an app today is a pretty sophisticated process, and you rely on your tools to keep you focused and effective.
So anytime Xcode horribly fails, that's the face of Xcode. That's the face of evil.
A number of specialized steps and tools. You need to test your code across various configurations. Your team reviews your code, and you integrate changes into a shared repository. You deliver to beta testers, and based on their feedback, you constantly refine your app. All of these steps are important, and it's important to get all of them right. You often have to jump between different apps, websites, and services to get everything done. All of this context switching disrupts your focus and pulls you away from your code. It's time to do something about that, to remove the friction and bring everything together. So
Let's use Python,
focus on creating
something that actually works.
experiences. That's why we created Xcode Cloud, a new continuous integration and delivery service built right into Xcode.
Yay, Xcode is now running on
Helps
other
you
people's
manage
shitty
every stage of
computers.
your development
Because
process.
that's what the cloud
Makes it
is.
easy,
The cloud
more
is
to do,
everyone's shitty computer.
Xcode Cloud was designed and built from the ground up to support development for all Apple platforms. It's deeply integrated into Xcode, saving you time by keeping you focused in one place. It leverages Apple's cloud infrastructure to offload your builds, tests, and even code signing for distribution. It integrates with Apple services like TestFlight and App Store Connect, as well as every major Git-based source control provider. It even has REST APIs to help connect to other aspects of your development process. And it's built with advanced security to protect you and your projects. This is the biggest investment we've made in our developer tools since the original release of Xcode. And all of it is inside the experience.
Jesus Christ, I remember the original release of
Create and
Xcode.
manage Xcode Cloud workflows in Xcode 13.
So, funny
Letting
thing
you
while I'm
set your
speaking
own
over this with her,
suites and designing
back in
and
high school,
distribution are handled
my
by
high
us.
school had
Xcode
nothing but
Cloud is easy to
Macs.
build,
Okay, they had
so
nothing
run
but
inside Xcode.
Macintosh
With
computers with the
multiple
original
tools,
hockey puck and everything like
it's
that.
already changing the
And
way we
what ended
work.
up happening
Many teams at Apple
is
have
that
integrated Xcode Cloud
I
into
took
their
a C++
development process,
and Java
including the team at my high
programming
school.
class because that was available at the time in my high school. And in order to get the compiler to work,
It's
it
incredibly
had to
easy
work
to
with
get started
xCloud.
with
And
Xcode
so
Cloud.
literally I worked
It
with
only
the
takes
two
4
teachers
steps.
for 2
Starting
days
with a
straight
prompt,
to
confirming your
get the
workflow,
compiler working through
granting
xCloud
access to
because
your
it
source
literally
code,
wasn't working.
and linking with App
So
Store.
every time I think of
Let's start the
Xcode,
process with Flutter.
I'm
Let's
saying
run a
xCloud,
sample here.
Xcode, I think of
Xcode
that type
Cloud
of shit.
automatically detects the products and platforms for my project, so I'll click Next. Then, I'll review the suggested workflow, which tells Xcode Cloud what to do and when to do it.
If you're
The
wondering what I'm
default
doing on my
actions
phone, I'm
build
updating
any
our
change
Instagram.
I make, which is exactly what I want. Now, Xcode Cloud will securely connect to the hosted account for my source code. I've already granted access using my credentials, so I can just move on. Finally, Xcode Cloud recognizes that Fruta already exists on the App Store and asks me to confirm the information. If your app isn't registered yet, Xcode Cloud will do it for you. I'll click Complete and start my first build in the cloud. When the build is finished, I'll be able to view the results in the Report Navigator. And just like that, I set up continuous integration and delivery for my app in 1 minute, all from within Xcode. Let's take a closer look at how results are presented.
I will give props for
Cloud tab in the
Apple
Report
for
Navigator
putting
shows
Sister
that
of
the
Color
present
as a
workflow
representative for
will be
coding.
viewed
That's
by
at least
branch or
cool.
pull request. Selecting an individual build brings up its overview with information like how and when it was started, which Xcode and macOS versions were used, and the status of all the actions. You can even check out the source or initiate a rebuild. While the default workflow is great for getting started, Xcode Cloud gives you even more power to accomplish goals like analyzing an app or deploying new releases to TestFlight or the App Store. My team wants to run our iOS tests on every new pull request, so let's set that workflow up now. I'll go back to the Xcode Cloud product menu, selecting Manage Workflows this time, and I'll click Plus to add a new one. I'll name the workflow Pull Requests, then edit its start conditions to run on every pull request that targets.
I want to see one named Regular
I
Expressions.
want our tests to run on the public beta versions of Xcode and macOS, so I'll set that here. Next, I'll look at the workflow's actions, where I'll add a test action, then select an existing iOS test plan from the project. To get broad testing coverage for my app, Xcode Cloud recommends simulators for me to use. With just 2 clicks, I get a curated set of iPhones and iPads for my workflow. Now that's pretty neat. Our team also needs to be notified when a build succeeds or fails, so I'll add a notify post action and add our team's Slack channel. By clicking Save, our workflow has been added to our product on Xcode Cloud. Now, my team will have added confidence in the changes we're making.
There's so much more you can do with workflows, including running custom build scripts and using Xcode Cloud's webhooks and APIs to integrate with other systems you and your team depend on. And the workflow management and build reports you just saw in Xcode are also available in App Store Connect on the web. This makes it easy for you or other members of your team to use Xcode Cloud from anywhere. Now that you've seen the basics of working with Xcode Cloud, let's see how it helps you in each specific area of your development cycle. Writing good tests and running them repeatedly is critical to creating a quality application. With Xcode Cloud, you'll be testing your code more thoroughly, more consistently, and more efficiently. You can configure your Xcode Cloud workflows to run multiple test plans across multiple platforms, device simulators, and OS versions, all in parallel. You can also run your tests in Xcode Cloud on beta OS releases before you even download the betas to your own machine. So Xcode Cloud will help you test more, and Xcode 13 will help you test better.
Our app, Fruta, supports the light and dark appearance, portrait and landscape orientations, and localizes to 2 languages.
Yay!
I've been working on
dark mode, hacker's best friend, which is why we wear shades. Everything needs to be dark.
Here in my test code,
Including
I'll adopt
me.
this simple XCTest API to make these tests go even further by automatically running each test in each variation. Let's look at that test coverage in Xcode Cloud by selecting the most recent build and the workflow test action I have configured. Results are displayed in the familiar Xcode test report. These tests ran across a set of recommended iPad simulators running iOS 15, once per configuration, capturing screenshots all along the way. Xcode 13 has a brilliant new way to review those results. From the Editor Options menu, I'll enable the new Gallery view. The screenshots from my test are displayed in every variation, and images from each test presented together. I can zoom out even further to see all images, and when I find one I'm really interested in, I can see it at full resolution using Quick Look.
I love that even in a developer's video, they're still doing the whole like images and video and shiny things as opposed to like, can you click a regular expression button and it does all of that for you sort of thing.
Sometimes the test passes and sometimes it fails. We've all been here before, and Xcode 13 is here to help. I navigate to the test source, click on the test gem, and choose Run Test Repeatedly. Let's get a better sense of reliability by running it 100 times. If I wanted to do this before, I'd have to run the test many, many times myself. Now, I can sit back as the tools do all of the work. As I suspected, Xcode is showing this test is very unreliable. There must be a problem in my code. But until I can fix it, I'll adopt the new expected fail API and include a message about reliability for the rest of my team.
That sounds like the API that's in every single modern software, the expected to fail API.
The Test Again feature, available from the product menu. Xcode remembers what I did last time, so it's really easy. My test is still raising assertions, but it's not failing anymore. And I have a gentle reminder to fix it down the road. That is exactly what I need.
As you can see, Xcode 13 and Xcode Cloud help you find and address issues in your app or your tests faster than ever. Tests are one form of insight on your code. Another is input from your peers through code reviews and pull requests. To keep you focused on your code, Xcode 13 brings these discussions with your team directly into the editor.
I've created a pull request from the feature branch I've been working on. My feature allows users to favorite the most delicious smoothies. In the navigator on the left, you can see
Yuck, I don't want any of his smoothies.
It shows all of the files I've modified locally, my pull request, and the changes that are included. When I select the pull request, I get a full overview of all the activity and the conversation going on. And as I scroll, I see my description and the interesting events in time, as well as any code feedback from my team and new commits that I make. But we're using Xcode Cloud, and our pull request workflow is building and testing every commit.
I love his accent. He says Xcode Clyde, not Xcode Cloud. The official name for Apple's cloud is Clyde. That's it. It's official. Hi, Clyde.
When I navigate to the source code, I see comments from Rhonda in my editor. This code requires the user to be logged in, so it needs to be reworked to allow signing in before favoriting a recipe. I'll reply to let Rhonda know that I'm working on a change, and also give her a heads up. This might crash in the build if she doesn't sign in first. Beyond pull requests, Xcode 13 makes reviewing local changes really easy too. As I navigate to a file that I'm working on, Xcode automatically displays the diff of my changes against the latest revision in this beautiful new inline presentation. I can use the updated revision selectors to compare my local changes against any branch or tag in history. Best of all, I can use code review in any editor, even when I'm using multiple editor splits across different files in my window. And now with two options, inline comparison and side-by-side, I get to pick the perfect presentation for what I'm
Now,
working
to be
on.
fair, I know a
With one
lot
left
of
code change and comment,
code
now I can
editors and
easily
developing
go
platforms
to
that do
review
that, but
and
you do have
respond
to
to
configure it
insight
a
from
lot
my
in
team.
order to display it like that. So that's nice that it's in one click.
Part of delivering a great
Ah!
experience is getting your app into the hands of your team and beta testers. Xcode Cloud makes that process effortless. Xcode 13 now uses the cloud to securely obtain and manage everything you need to code sign your apps. This means you no longer need to worry about keeping your certificates and profiles up to date on your Mac. The archive action in your Xcode Cloud workflow uses the same system to sign your app for distribution. And by adding a post action to your Xcode Cloud workflow, you get automatic delivery of betas through TestFlight to all Apple platforms, including macOS, with the new TestFlight for Mac. Once you've delivered your latest build, you'll get even more insight from your beta testers. Xcode 13 includes major improvements to better connect you with the same diagnostics and feedback found in App Store Connect. Crash logs from TestFlight apps are now delivered directly to the organizer within minutes. And the organizer now shows the written feedback a user attaches to a crash report. This gives you valuable context when analyzing the crash and a broader view into your app's usage.
After Andrew's test passed, Xcode Cloud submitted the build directly to TestFlight. I just received a notification on my phone for a new iOS build of Fruta, and there's the Mac version from TestFlight for Mac. Since Fruta is a multi-platform project, I'm getting this new build in both places at the same time.
That's pretty
I'm really
cool for like
excited to
test and
install this
deployment.
build and see how the new feature feels, so I'll do that now. I suspect there are still a few rough edges. Maybe the app will crash if I try to favorite this smoothie, and sure enough it does. I can use TestFlight's crash feedback UI to let Andrew know. I'll explain what I was doing when the app crashed, and he'll be able to fix the issue and add a test to ensure this is caught earlier next time.
I've been looking at our most recent app releases in the organizer. When I filter to the last day, here's a crash Rhonda experienced just a moment ago, fully symbolicated and ready for investigation. The new TestFlight feedback inspector includes her comments, information on the app build, version, and her device. And I can even contact her to learn more about her experience. What's even better, Xcode knows where in my code this crash came from. So with one click, I can open it in my project. The debug navigator has the full backtrace. My source editor highlights the assertion, and my pull request conversation displays too. It's incredibly exciting to have what I need to fix this problem right here in Xcode.
We've brought everything you need into the tools you use every day. Test results, comments from peers, and user feedback, all to give you greater insight and help you deliver the next great version of your app. Xcode Cloud was built with your privacy and security in mind. Your
Told
data,
you,
including your
this is
source,
what they've been doing
access
even at the
points,
keynote, is
locations,
just
and build artifacts.
going full
Xcode
ham into
is the
privacy
least
and
amount of
security,
data
which is nice to
possible
see a big
for
company
user
do that,
use.
but all of them are doing
This is
that.
a
And
huge
again,
use-charging
it's like having a
opportunity.
VPN
With
where
Xcode 13
your stuff might be
Xcode
protected by
Cloud,
third
we'll be
parties, but
building and delivering
Apple has
quality
direct
apps
access
across
to all of
all
your
Apple
stuff. Apple
platforms
sees
in
everything that
less
you
time
do. So
and
as
in
long as you're
less
comfortable with
effort than
Apple,
ever.
like looking at your porn and knowing your
Xcode
social
Cloud will initially
security,
be available as a
then
free,
you shouldn't
limited beta.
be worried. But
Developer
you
programming
know, if
available
you really want
exclusively
privacy
right
and
now until
security,
developer
modified
notification.
Android
We will
and
gradually add
Linux
more
will
teams
get
as
you
we
there.
work towards making this available to all developers next year. We'll provide more details on pricing and availability this fall. You can check your registration status from inside Xcode 13 or the Xcode Cloud tab in App Store Connect. In addition to everything you've seen here, We have a huge list of improvements and features in our developer tools that you can learn about in this year's sessions, including some terrific enhancements to Swift support in Xcode. That's just the start of an exciting story for Swift this year. To tell you more, here are Josh, Holly, and Matt.
I am definitely not a fan of Swift, by the way. Everyone keeps pushing Swift as like this super easy to learn beginner language. And I know a lot of people who either quit programming or got stuck in it because that was their first one. And even though there's technically most programming languages are beginner languages because you're learning concepts rather than than the language itself at the time, but Swift is so convoluted like an apple pie. At least when I was introduced to it, it just gives me a headache when I look at it. See? That bullshit right there. That is horseshit. Everyone that I've ever seen started on Swift, that is horseshit right there.
Technology is great for you is adopting it ourselves. High-profile apps, like music, have been written in Swift for years now, and system-wide features like widgets have been designed from the ground up with Swift UI. Learning Swift and Swift UI gives you a common, powerful set of tools and APIs to build fully native apps for all of our platforms. And because Swift itself is open source, we've been able to work together with many of you to deliver tons of new features and capabilities over the last few years. Now, one of those capabilities, which is crucial to building any app, is support for concurrency. And here's Holly to tell you all about it.
Whether you think about it or not, you are writing concurrent code today. Concurrency enables your apps to perform multiple tasks at the same time, which helps your apps stay responsive to user input while doing work in the background, like a weather app fetching forecast data while the user selects a city. And it's essential to taking advantage of multi-core processors to achieve high performance for heavy computation, like rendering complex visual effects in a video app. But without language support, writing concurrent code is really hard to get right. So, we're bringing first-class support for concurrency to Swift. Our approach to building concurrency into the language follows the same core principles.
Doesn't Swift concurrency sound like some sort of like evil Star Wars corporation villain or something? Like this would be something that would be in Neuromancer, the Swift concurrency versus the Techno unit.
Taken a modern approach to building concurrency into Swift. Today, we think of modern code as structured and easy to express what you want to do. Unfortunately, most of today's asynchronous code uses completion handlers that are unstructured and hard to express.
That is very true.
To make expressing asynchronous functions easier, we've built the modern async await pattern into Swift. Now, you can mark an asynchronous function with the async keyword. When the function is called, you use the await keyword to indicate that other work can be done while the caller waits for the result of the async function. To understand the improvements async await brings over completion handlers, let's walk through an example. When I'm not working on the Swift compiler, I like to dance. To prepare for a show,
that's a weird segue. It's like, when I'm not programming Swift, I like to dance. That's like saying to me, when I'm not programming in Python, I'm an alcoholic. It's just so weird.
Prepare for show that uses completion handlers. What this code is trying to accomplish is really simple, but the code is convoluted.
Yes, that means it's Swift. If it's convoluted, that's the Swift programming language.
So the code is really hard to read. Adopting async await in this example leaves us with code that's now in a straight line. This code is so much easier to understand.
To me, this isn't a feature. To me, this is what Swift should have looked like from the beginning. If it really wanted to be, because it's still weird, but I can follow it better. This should have been the default, not the new feature.
Too. So it's easy to add conditional logic, so the function behaves differently during a rehearsal. Async await makes writing asynchronous code easier by leveraging the tools you already know. It's also easier to introduce concurrency where you need it, using structured concurrency. Structured concurrency is a way of organizing concurrent tasks to make them easier to reason about. Let's introduce concurrency into Prepare for Show. Right now, the function waits until the dancers finish their warm-up before starting to fetch the scenery, but these tasks could be done in parallel. With structured concurrency, you can easily create concurrent child tasks using async await with local variables, like this. Now, the code uses async let variables to create child tasks that execute concurrently with the parent. So, the company warm-up and fetching the scenery will run concurrently with the rest of Prepare for Show. When we need the results of those child tasks, we await the results. Because fetch stage scenery executes concurrently, it's possible that the result isn't
Yeah,
ready
no,
yet
exactly.
when
Like,
Prepare
while
for
this
Show
is an
starts
important
using
thing
it.
in
So
programming,
accessing the result
to me, like,
must be done
the way it
asynchronously.
looks is what Swift should have
The first
looked like if it
concurrency
wanted to be a
model is
more
also
simple, easy to
designed
follow
to be
language.
safe. Just like Swift eliminates null pointer mistakes with optionals, the compiler will now help eliminate common concurrency issues by ensuring that access to shared state is safely coordinated between concurrent tasks. A core part of this safe concurrency model is built around actors. Actors are an industry-proven model for safe concurrent programming and a powerful synchronization primitive.
Please don't bring up actors. We already went through the Johnny Depp Amber
Conceptually,
Heard
actors is
thing,
an
which is
object that
probably the
protects its
worst battle
own
of regular
state
expressions
by
I've
only
ever seen.
providing mutually exclusive access. This completely eliminates concurrent access and the low-level data races that come with it. This concept might sound familiar because it's similar to a pattern that you might already use for classes with a dispatch queue, which was itself inspired by actors. In this pattern, the instance properties in a class are carefully accessed using a serial dispatch queue to maintain mutual exclusion. But this pattern is prone to mistakes. There's a lot of boilerplate, and it's too easy to forget to manually use the queue just once and introduce a race condition into your code. To solve these issues, we went back to the core idea of actors and built it into Swift as a first-class construct. Now, you can declare an actor type in Swift with a simple keyword. It has the same structure as the constructs you already know, and there's no need for manual synchronization. With actors built into the Swift language, synchronizing access to actor state can be managed for you automatically. An actor can access its own properties directly, and interacting with an actor externally uses async await to guarantee mutual exclusion. The actor concept is so powerful that it also solves another common source of concurrency problems, which is proper use of the main thread for things like UI operations. Today, you have to manually dispatch to the main queue each time you call an API that must be run on the main thread.
Yeah, it's like scratching your balls with a cheese grater. I love it.
Introducing a way to state that an API is always run on the main thread using the main actor. Making sure that an API always runs on the main actor is as easy as annotating the declaration with the main actor attribute. Just like with other actors, calling a function that runs on the main actor is just an await away. Altogether, this means it's easier to write safe concurrent code that you don't have to manage yourself. As we build support for concurrency directly into the language, it gives us the opportunity to better optimize the performance of your concurrent code. With async await, the compiler understands the concurrency of your code, which allows for more effective optimizations. This includes reducing reference counts and inlining, as well as addressing concurrency-specific performance issues, like excessive context switches. And of course, your concurrent code will get even faster as the compiler gets smarter in the years ahead. There are tons of asynchronous APIs in the SDK that you already use in your apps. We've refined the SDK to enable async await with these asynchronous APIs, so you can immediately adopt async await in your existing code. And we didn't stop there. We've added new, purposely crafted APIs that take advantage of async await for when you work with URLs, when you're doing asynchronous I/O, and we even added support for asynchronously iterating line by line through a file. Async await makes it natural to express asynchronous code, Structured concurrency makes concurrent code easier to reason about, and actors help you safely model shared state in a concurrent program. The Swift concurrency model brings together these fundamental pieces to make you more efficient, give you more power, and allow you to have more fun building concurrent apps. Of course, the language is just one piece of the puzzle. The frameworks built with Swift are just as important. Now, back to Josh.
Swift is the foundation for the next generation of APIs. With new features like concurrency, we're evolving the language and frameworks together, so you'll see immediate benefits across the SDK, including with key technologies like Swift UI. 2 years ago, we began to reinvent UI development on our platforms. We started small, with a core API that allowed you to adopt SwiftUI incrementally in your existing applications. Last year, we added API to describe your app's lifecycle, enabling you to develop apps entirely in SwiftUI from your first line of code. And this year, SwiftUI is taking another huge step forward, helping you deliver great experiences to all your users across all Apple platforms. We focused on APIs that we know are critical to your apps because we also needed them to build ours. And your feedback helped us enhance the most important APIs while also refining the development experience. This year, we've started using SwiftUI in apps like Maps, Photos, and Shortcuts. And we've rebuilt iOS apps like Weather, system interfaces like the Apple Pay payment sheet, and brand new watchOS apps like Find My, entirely with SwiftUI. To see just a few of the enhancements that make this possible, let's take a look at some ways that we can improve Fruta. We'll start with List, the most ubiquitous component across all our platforms. We can now easily add a swipe action to mark a smoothie as a favorite. Adding pull to refresh is just one more line. And Swift now makes it easy to limit a modifier to a single platform. In this case, iOS. Adding a search field is just one more line. Now, we could stop there, but let's add some search suggestions as well, which will be shown while we're typing. Now let's test it right here in Xcode. We have a swipe action now, pull to refresh, and full search support, including suggestions, all in just a few lines of code. Next, let's refine Fruta's accessibility support.
I'm going to comment in a moment.
First, a new modifier, which adds accessibility rotors, can make our app faster to navigate with VoiceOver. And second, we'll improve the accessibility of this custom stepper control. Custom controls are often a source of poor accessibility, but we can now simply inherit the full accessibility implementation from the standard stepper. Most SwiftUI APIs are available across all platforms, but we're moving platforms forward individually where appropriate as well. Let's add a multi-column table to our macOS app. I already added a new file for this, so we'll just add the new table component here. And then within it, we'll just add 3 columns of data. Now, let's run the macOS version of our app. We'll find a search field placed right where you expect it in the toolbar, and suggestions appear just below it while we type. We can now switch to our new multi-column table that we added, and we'll see it's displaying the search results as well. And of course, we can clear the search to get them all back. Now, let's switch to recipes and turn on VoiceOver. With VoiceOver, we can easily access the rotor that we added to quickly choose a smoothie from the list. And VoiceOver interaction with our custom stepper now behaves exactly like a standard stepper, making it easy to use for all of our users. We're building our apps using these new capabilities, so we know
Sadly,
that you'll find them helpful in yours as well.
because I was updating on some things. And actually, give me a moment. I'm going to take the cam off because I have to answer a phone call that I missed, and then I'll be right back to commentating, okay? See you guys in a moment.
In the Fruta app, views like this are made more interesting by adding a background image. And they're kept legible by applying one of those new material styles behind the content. Content responds dynamically to this background, So instead of the gray normally used for secondary content in an opaque context, SwiftUI will automatically apply vibrant rendering to text, symbols, and even standard UI like separators. So with just one line of code, you can get great looking results like this automatically. And there is so much more. With all of these improvements, SwiftUI is the best way to build great experiences for all your users across all our platforms. And this year, we're bringing app development with SwiftUI to iPad in Swift Playgrounds. It's so much fun, and Matt will show you all about how it works.
You know Swift Playgrounds provides a great way to learn how to code, and it's been used by millions of people to expand their knowledge of Swift. And beyond being a great way to learn, we know a lot of you already use Swift Playgrounds to experiment, sketching out new ideas and playing with the latest features in the iPadOS SDK. This year, Swift Playgrounds 4 is taking a huge step forward by allowing you to build apps and even submit them to the App Store right from your iPad. With the ability to create apps on iPad, you can be more productive in Swift Playgrounds than ever before, allowing you to work on your ideas wherever you go, on whichever device you prefer. And with a new package-based project format, you can seamlessly bring your work between Swift Playgrounds and Xcode. Let's dive in and take a look. This is Swift Playgrounds 4. It's got all of the great learn-to-code content
And
that's
I'm
helped
back.
inspire new developers around the world. And now, you can create projects that let you build SwiftUI apps. Let's make a new one now and see what we can build. I'll open the new project I
I
created.
love how I get non-distracted
In an
after
app
most of
project
the
in
coding
Swift
happens.
Playgrounds, my code is on the left, and the result of my work is on the right, just like I'm used to. What's new is deeply integrated support for SwiftUI, with live, interactive previews powered by the same technology used in Xcode.
Oh, we're still on
My new
Swift.
project template
Why couldn't
comes
we
with a
do
Hello
Metal
World placeholder,
API?
which I can easily replace with a text view of my own. I'll start typing text, and right away, I get helpful suggestions from Code Completion, which new in this release appears right below my insertion point. I'll accept the completion and write my own hello message. While I'm typing, my app updates live to show my changes with each keystroke.
Why is it that many
Now,
line of
let's have a little
code to write hello
I'm going
world?
to replace this static text with a button. I'll select my text view and then add a button from the library. Here in the library, I can browse and search through assets in my project, as well as the SwiftUI views, modifiers, colors, and SF symbols provided by iPadOS. For now, I'll just add my button. I'm going to fill the action in with a simple print statement. For the body, I'll use a label with a system image. The text will be "say hello," and the image will be the SF symbol for Swift.
This is some neat
I've now
automation,
added
though.
an interactive button in my app. When I tap it, the print message I wrote appears as a message bubble at the bottom of my screen. If I open the console, I can see a history of print statements that have been executed since I opened this project, and it updates in real time as I interact with my app. Now, this button is purple because that's my app's accent color, which Swift Playgrounds chose for me when I created my project. If I open the document sidebar, I can access all of my app's top-level settings, like its name, accent color, and icon. As much as I do love purple, I think this smiley face will look big and bright and orange. So I'll change my accent color here, and both my app's icon and the tint color of the button I just made will update to reflect the change. This has been really fun, but Swift Playgrounds isn't just for experimentation.
Nothing about Swift is
I've got
fun.
another app that I've been working on for a while. I use this app to track the amount of time I spend on my favorite hobbies, and I think others might find it useful as well. I can get a feel for what the installed app would look like by taking it full screen. Now, I can explore my app in its full width 2 or 3-column layout. I can jump out of full screen and return to my code whenever I like.
That's pretty cool.
This feels great, and I think my hard work is ready to share with my friends and family with test
My
flight.
biggest problem with Apple
Anyone
is
with a
the
developer
way
account
they
can
have
upload
their
apps
people
from the
talk
app
to the
settings area
camera.
once
It's
they're ready
super
for App Store
unnatural.
Connect.
Like,
When
no
I tap
human
the
talks
upload
like
button,
that.
Swift Playgrounds builds, packages, and uploads my app. I can then hop over to the App Store Connect website and make my app available via test flight. And when it's ready, submit it to the App Store and share it with the world. And that's a quick look at Swift Playgrounds 4, with the ability to create apps using Swift UI right on your iPad. Swift Playgrounds 4 will be available later this year. We know you're going to love having the freedom to develop your app ideas wherever you go, on whichever device you prefer. And now, I'll hand it back to Susan.
And now we're at Apple's obligatory nature shot.
Experience the world is through visual communication, and that's a big part of using Apple devices. Our technologies for graphics, displays, and augmented reality are front and center. Whether you're glancing
Was
at
that
the
the
always-on
hint of the
display on
VR?
Apple
Augmented
Watch,
reality, was that the hint of the
enjoying
VR?
ProMotion as you work with video tools on iPad Pro, playing a game on your iPhone, or creating immersive 3D content on your Mac.
Apple
And now,
games.
Myra and Eric are going to take you through what's new this year, starting with augmented reality.
AR is a powerful technology, and thousands of you
Okay.
are already using it in your apps to transform how we all work, play, and express ourselves. With over 1 billion AR-enabled iPhones and iPads around the world today, there's never been a better time to start adding AR experiences to your apps.
Pokemon Go.
Building an AR
Pokemon
experience.
Go.
Historically,
Pokemon
building
Go.
great AR apps has required deep
Ooh,
knowledge
pretty.
of 3D modeling and a mastery of sophisticated rendering engines. However, we want all of you to be able to create amazing AR experiences.
Apple wants everyone at DCG 201 to make GoSee AR applications on the App Store. Got it.
Our 3D rendering, audio, animation, and physics engine built from the ground up for AR. RealityKit makes rendering immersive AR experiences simple, featuring photorealistic rendering and camera effects like noise and motion blur. RealityKit also takes advantage of our latest hardware, like the LiDAR scanner, which enables virtual objects to behave just like they were really there with people and object occlusion. And it's all written in Swift. Today, we're announcing RealityKit 2, a huge update that gives you more visual, audio, and animation control and tackles the most difficult part of making great AR apps, creating 3D models. If you've ever created one before, you know a single model can take
You'll
hours
know it's a
and
pain in the
thousands of
ass.
dollars to make. Now, with Object Capture, you'll be able to make 3D models in minutes using your iPhone to capture 2D images of an object and the Object Capture API on Mac to turn these images into lifelike 3D models, optimized for AR. This process is so simple. You start by taking a series of pictures with your iPhone or iPad to capture all angles of the object, including the bottom, because we support flipping the object and automatic foreground segmentation.
Because it's June, Pride Month, so we love bottoms.
Provide excellent guides to help streamline your workflow.
They really want people to take pictures of their dicks to import their dicks into 3D, into AR and Apple
You
devices.
start a new photogrammetry session in RealityKit that points to the folder of your captured images. Then, call the process function to generate the model at the desired level of detail. It's that easy. Object Capture enables you to generate USDZ files optimized for AR Quick Look, so users can view them in Messages, Mail, Safari, and other apps. You can also generate USD or OBJ asset bundles from the Object Capture API that can be used for ray tracing and other post-production workflows. Turning real-world objects into 3D models has never been easier. You can get started using Object Capture today with our sample code, and we're working with some of the leading 3D content creation.
Now with sample code and Apple, Apple has led the way into advanced augmented reality dick pictures.
Cinema 4D and Clone, available
Cinema
later this
4D.
year. It's easy
What
to
about
bring
Blender?
Object Capture models into Xcode and use the new RealityKit APIs to add effects. My team and I tested Object Capture by scanning our favorite food, and we built an AR app clip
Sure,
to share our
nobody
recipes,
scanned their
which
butts,
includes
did
the
they?
AR preview of
Oh,
the
a
dish.
turd.
The chocolate croissant we captured using Clone
That's a
is
turd.
actually
That's not a
version of
croissant.
Mocha
If you
that
bought
some of
that
my
at a
teammates
bakery, you should get your money back.
add it as another recipe to our app clip. I'll start by dragging the 3D model of my croissant into my AR app project.
It's croissant.
Next, I'll anchor it to my app clip code using ARKit and initialize a model entity for the asset. I can always fully examine the 3D model directly in Xcode Quick Look at any time while building my project before deploying my app clip. We've used the new Reality Kit APIs in our app clip to add effects to each AR dish to make it more realistic. Because Reality Kit is a native rendering engine, we can fit multiple AR scenes or recipes into the app clip. Let's check it out.
God, their presentations are so awkward.
When I scan the app clip code, it launches the app clip and then anchors the chocolate croissant right on top.
We
make the
really need
croissant more
to.
realistic, we use the
Oh,
new Reality
we
Kit
are totally
custom
gonna make
surface
Goatsy
shader
with
to
that
get
at
nice and
DCG
light
201.
and pull back on the ambient
Thank you,
exposure.
Apple. We are gonna get on that. By the end of the year, we're gonna have AR Goatsy that pop up on Apple's weird bullshit proprietary QR codes.
With the new procedural geometry API to layer in a flipbook shader.
I love that this is what Apple's doing with their advanced M2 graphics chips and not like, I don't know, run Crysis on it or some shit like that.
Expanded with the size of the pizza. For this barbecue chicken dish, we've added a full screen post-processing fire effect.
Apple is just like, we have like more advanced graphics than Nvidia and what's the other one? Nvidia and ATI combined. But, instead of giving you something like Elden Ring native port for Mac, we're just going to put Fire and Steam effects in our bullshit AI development application.
And how you use these new APIs. These are just some of the exciting new improvements we have for AR that enable all developers to create 3D models to build more immersive and lifelike AR experiences. One of the foundational aspects of what we do in ARKit and RealityKit is our graphics technologies, and Eric will give us an update on what's new.
A core idea of how we build products at Apple is that we bring together the most amazing hardware and software. And our approach to graphics reflects that ideal. For years, we've delivered powerful Apple-designed GPUs for iPhone and iPad, paired with our Metal graphics and compute APIs to help you get the most out of our products.
Rock on!
And now, with the M1 chip, not only are we delivering an unprecedented level of graphics performance and power efficiency in our latest Macs and iPad Pro, but we have created a unified Apple graphics platform with a common architecture based on Metal, the Apple GPU, and unified memory.
Okay, what are you calling
that spans from iPhone to iPad to Mac.
Tell me the bullshit
And this
name.
platform enables a fundamental shift. Graphics workloads that previously required high-end workstations or discrete GPU gaming computers are now possible across our most popular products. For instance, the console-level performance of this unified platform has enabled developers like Larian to bring their AAA game, Divinity Original Sin 2.
They found the one game on Apple. They found the one game.
M1 and Metal's modern shader pipeline to enable the high-performance, immersive graphics in their survival game, Metro Exodus for Mac. But this graphics platform is not just
what version though? Exodus. Okay, Exodus. That's the newer
one. Now accelerating the next generation of professional GPU renders, like the all-new Octane X from Otoy and Maxon's Redshift render in Cinema 4D, now running Metal accelerated on the Mac for the very first time. So, to help you bring your graphics apps and games across all of Apple's powerful devices, we focused on two big areas this year: advanced graphics and gaming features, and powerful graphics developer tools. First, we focused on three key features essential to modern high-end games and GPU rendering algorithms. In order to accelerate complex mathematical operations, model the behavior of light, and represent realistic surfaces, modern GPU renderers need to interleave Metal graphics and compute commands in the same pipeline, which is why Metal can now call dynamic libraries and ray query primitives directly from your graphics shaders. And you can create even more photorealistic rendering with the new stochastic motion blur function in the Metal ray tracing API. For games to achieve higher frame rates with lower latency.
I didn't know Jack ported Ninja OS to Darwin.
The display. To accomplish this and take advantage of the awesome graphics performance of the latest iPad Pro, your game can use the Metal Presentation Time API and the ProMotion display to dynamically adapt your app's frame rate based on your desired latency between rendering and
all two Apple game developers are watching this.
Add support for adaptive sync displays. This means you can now take advantage of these ultra low latency and variable refresh rate displays for your Mac games as well. Now, high-end games with advanced graphics are often designed around using game controllers as input. And adding game controller support is a powerful
I
and
wonder how
easy
much
way to
Sony paid them to use the DualSense controller. It's literally in every shot.
Our game controller framework now supports the most popular controllers,
Where's
including
Switch?
support for the latest Xbox Series X wireless controller and the PlayStation 5 DualSense
Where is
controller.
Switch Pro? It's the best controller. Come on.
To make it even easier for you to bring your controller-based games to iPhone and iPad, we've added a new API so you can enable an on-screen virtual game controller with just a few lines of code.
APIs. APIs everywhere.
More valuable than ever, because in macOS Monterey and iPadOS 15, players can find the games their friends are playing, directly navigate to the app library to launch a game, and then hit the share button to record their favorite game highlights,
Oh, they
all
got it
without
to
the
work.
controller ever leaving their hands.
All
Now,
without
along with
opening
these
up
new advanced
Xcode
APIs
and
and
its
features,
shitty
Xcode
spaghetti
13 has powerful
execution.
new graphics developer tools for you to optimize and debug your GPU code, each designed to bring your modern high-end games and graphics applications to the next level.
I like that the
First,
error
when building
message is
advanced
the
GPU
Amiga
renders and
ball
games,
with like
GPU
a
shaders can
construction
get really
sign.
big. Debugging 10,000 lines of shader code across thousands of workgroups, all running in parallel, can take a really long time. To help you streamline this process, Xcode 13 adds selective shader debugging.
AKA
Here we're
the
using selective
Cyberpunk
shader debugging to teach you that,
2077
which
debug
functions
machine.
to debug within a much larger GPU shader. This can dramatically reduce the time it takes you to iterate and debug your largest shaders, which lets you develop faster and focus on adding features and performance to your GPU code. Next, high-end AAA games also require the latest in modern texture
What
compression support,
AAA games
which is why
are coming to Mac, especially day in and day of release? And I say that as a Nintendo Switch fan.
texture converter compression pipeline added all new gamma-aware pixel transforms and vastly
Like, I
expanded
think
support
the lower thing, because Linux gaming has rose a lot, the only thing lower than this is Stadia.
PC and iOS games. This makes it even easier to optimize your game's texture assets for each of Apple's devices.
I'd love to hear Mr. MacWright's opinion about this section.
Peak performance with your most advanced rendering. Xcode 13 adds an all-new GPU timeline view in the Metal Debugger. This powerful new view allows you to combine the best of visually debugging your Metal commands, resources, and buffers on the timeline of events, in addition to powerful performance counters and bottleneck analysis information. With Apple CPUs, GPUs, and Metal, we have created a unified graphics platform with over 1 billion devices, with the latest features and developer tools to enable you to unleash all new levels of capability and performance for your graphics pro apps and games. And now back to you, Susan.
Your apps can help connect people with ideas, services, tools, and most importantly, other people. Finding balance is just as important as connecting. So this year, we're enabling you to help users focus on your app.
Why are you in the middle of the forest? I feel like Apple keeps trying to compete because they're mad that the most famous image of a hill was on Windows XP, so they've been competing ever since.
Intimate experiences built across Apple platforms. We created a powerful new set of APIs that'll help your app create those kinds of relationships. Let's start with Hina and Matt to tell us about Focus.
Damn, there's a living room outside of my
new set of tools to help
price
people
range.
focus. These tools help reduce distractions so that people can be in the moment, and it starts with an entirely new approach to notifications.
I love how they're doing that even though the iPhone is a
Levels
distraction.
of urgency are clearly different, but they all behaved identically. They had the same look, the same haptic, same apparent level of importance. Now, with the new interruption level API, there are more nuanced ways for apps to convey different levels of urgency.
This is less of a focus and more of a like security level of how much you want apps to bug you for
Pick
microtransactions.
up their phones. You might want to use these for notifications that aren't time sensitive. Active interruptions will play sound or haptic, just like notifications today. Time-sensitive interruptions are designed to visually stand out and hang out on the lock screen a little longer if the user hasn't tapped on it. They'll also be announced by Siri if someone is wearing AirPods. And you'll want to use this for notifications that require immediate attention. Critical alerts are the most urgent
Imagine
category.
accidentally like hooking up to a Bluetooth speaker, so Siri is like, John, your bowel appointment is in 20 minutes.
Approved entitlement.
There's another category of notifications that deserve special attention: communications from people. If you have a communication app, it's important that you tell the system about your message and call notifications. The system will then use this information to tune your notifications' appearance and behavior, which will help people better interpret them. Once implemented, your notifications will go from the standard appearance to looking like this, featuring a prominent avatar with your app icon superimposed. And the same avatars will be used elsewhere in the system, like in the share sheet.
I'm so excited to see those avatars.
This
All right,
part's kind of stupid, so
notifications
I'm
are
going
a
to
really
skip ahead
effective
here.
way to get people's attention, but they could also be kind of ephemeral.
They're not getting
If
my
they're not well
attention, so I'm
timed,
skipping this.
people can easily miss them. To help users engage on level
By setting a
across their devices and ensure that those restrictions remain in place until the parent says otherwise. With managed settings, your app can set a number of restrictions like locking accounts in place.
This is the other thing I kept seeing in the keynote was their parent prevention system, which I know is going to be cracked in about 4 months, and it's going to be kind of interesting to see, because like parent restrictions are always like the beginning of like how kids kind of get into hacking a lot of the times, where they're trying to access the lewd websites and stuff, and like then they get into, you know, coding and anime waifus and Linux distributions and end up coming up to one of our meetings. I'm going to skip this section though.
Controls framework is at the heart of our privacy model, and it serves two key user-facing
I will see this part though.
First, it allows parents to authorize your app for management with their iCloud credentials, ensuring that the device is for a child in that family. And it provides a personalized experience.
Man, if this gets cracked, there's going to be so many creepy people. So many creepy people.
Restricted, all while protecting user privacy. We wanted to allow parents to manage and restrict the apps and websites that their children use, but do so in a way that doesn't divulge their private application and web browsing details. So, rather than returning a selection of raw bundle IDs and URLs, the picker will return opaque tokens instead. These tokens allow your app to keep track of which apps and websites a parent wants to manage, all while ensuring that parents are the only people who can access this highly sensitive information.
It's always amazing how Apple can talk so much bullshit without saying the word blockchain once.
Use a token to limit access to a specific app or website with managed settings, or gain insight into app and website activity.
Something so it's basically token obfuscation then.
Until today, with the device activity framework. With the tokens provided by the activity picker and family controls, you're ready to leverage the power of device activity. You can register unique time windows for different apps and activities, each emitting a warning like 5 more minutes left, and a completion event. Once your app receives these events, it can react accordingly by changing restrictions, limiting access to...
We're adding new useful and...
All comes down to this concept.
We'll create a new type that conforms to video because it's playing in your app and streaming from your servers as it always does. Now,
I saw some code. Let's watch this.
Let's see how easy it is to adopt group activities in a simple media app and take full advantage of the framework. There's just a few steps to get your app ready for shared playback. First, we need to define our group activity. We'll create a new type that conforms to the group activity protocol and supply a URL for everyone in the group to load. If your app already supports deep links to content, you can use those here. We'll also provide some basic metadata to the system to customize system UI like confirmation dialogues and notices. Next, we need to hook up our play buttons. In our play function, we'll create a new activity and call prepare for activation on it. This is when the system presents that confirmation dialogue you saw earlier. You can call this without any extra conditionals. It'll return immediately if the user is not on a FaceTime call. Now, let's turn our attention to handling incoming activities. The initiator joins the session just like the other participants, so the code looks the same for everyone. Here, I'm using Swift concurrency to create a new model with each session that's delivered. We'll then join the new session once the player appears. You can observe the session for other state changes to update our UI accordingly. Finally, let's make sure we synchronize our players. Step 1, grab your AV player and call Playback Coordinator, coordinate with session, passing in your session. Step 2, there's no step 2. That's it. That's all you need to do to get frame-accurate AV sync with group activities and AV player.
All right, honestly, that's pretty cool.
The system handles the rest.
Now, we've talked a
Of
lot
course,
about
the
shared
only way they can do that is because they also lock down the hardware, but that is still pretty cool.
power even the most ambitious experiences that you could dream up. So we started building on top of the fabric that powers Group FaceTime today, providing your app with a fast and reliable data channel.
Oh boy.
By taking on the job as group leader, our servers orchestrate a centralized state for the entire group.
Those servers are going to get pwned so hard. Well, if the keys are decrypted or broken, that's going to suck.
You can create immersive experiences, from turning the page on a shared book to seeing the strokes that someone has drawn on a shared whiteboard live.
Oh, I'd see those strokes.
We want to really inspire you to take full advantage of our APIs and bring your users together like never before. But before we show you a demo, we're going to need to call in a little extra help with this one.
Okay. They're going to just bring Steve Jobs back from the dead?
Bonjour.
Hey everyone, thanks for joining. We're going to need your help with this one last demo to really
Oh, they're going to do that obnoxious thing of using the tool that they are in order to build the tool.
whiteboard demo app to show you what can be done with group activities. Now, by opening a shared canvas, I'm starting a new activity with the group
Okay, this
to
is
draw
just drawing
together.
shit. I'm skipping.
Now we're all looking at the same canvas, and we can interact. Thanks for the help, everyone.
The best part is, everything you just saw, share play activities, playback synchronization,
Okay,
and
this is the
fast
end
secure
bit. We're
data
gonna
channel,
watch the end.
you get all of these benefits just by integrating your app with Group Activities Framework. SharePlay is a great new way to elevate your app's content and help you create a more immersive experience for your users. We're eager to see the new shared experiences that you'll come up with using group activities. Now, over to Susan to wrap things up.
And now we're back outside, where the air supposedly
We
exists.
believe the advances you've seen today will help you continue to build apps that make a difference. We're building tools that streamline your workflow and make it easier to build great apps faster. We've made it easier to build immersive content, games, and tools for professional creators. We've shown you how your apps can help users connect while still focusing on the things that matter most. What you've seen today,
Except on the platform Mattermost, which is an open source chat system.
much more to check out this week that we haven't even had a chance to touch on. We know you're going to build something awesome, and we can't wait to see it.
So that way they can blacklist it on the App Store, as well as that way they can take you to court and get mad when you break and open source all of their stuff. So we're going to switch back to face mode here. Ta-da! So now I'm like super huge and everything, like I usually am. But yeah, that was the state of the platform State of the Union that they call it. I get that confused because Apple thinks they're their own country. I fucking hate it. So yeah, that was that live stream that we didn't get to watch live, unfortunately. Hack the Planet just saying good day. Hi, Dark Arts. Quick thing. A lot of you have probably noticed that, and by the way, for anyone who's following, awesome. Thank you for still sticking around. For all of those who are new, if you like the content you're going to see and some of the content you're going to see later this month, we totally invite you, as I try to get rid of some of the sunscreen on my nose, to like, share, and subscribe on your platform that you're watching, whether it's Twitch, D Live, or YouTube. If you're on YouTube, make sure to click that bell notification and turn on all notifications because YouTube sucks and doesn't do that automatically. The stream's not done yet, I will say. I just want to get some stuff out of the way real quick. You probably noticed that not only have we not had a Master of Unlocking for a while, but also because we also haven't been live streaming a lot recently. I'm trying to change that, but that is simply because I'll probably discuss it in a future stream. But I'm personally going through a lot right now. Not like I'm fine. Like I'm not like suicidal or something. You know, it was Mental Health Awareness Month last month. There's so many resources out there. We love you at DCG 201. You know, that's not the issue. I've been having to do a lot of adulting since the start of May, and it's still going on. and I'm going to be doing more adulting tonight, tomorrow, and the rest of the week. In fact, when we do play the videos, that's what I'm basically going to do is run out and do a bunch of more adulting. So that's why we're playing the videos, because that's kind of my excuse to do that. So I am trying to get back to Master of Unlocking. There might be, worst comes to worst, one normal Master of Unlocking stream. And that I am right now in chats with multiple people of doing 2 Master of Unlocking specials. So Master of Unlocking, the lockpicking show that I do, has not gone anywhere. It's simply that I have a lot of stuff to do. Crypto Barons is still going on. That's going to happen this Saturday. We're going to be doing the Summer Game Fest. We're going to be looking at cryptocurrency and blockchain-based games, which is a topic I've been wanting to do for a while. I'm going to try to do Patch Tuesday tomorrow, and just to note, I'm going to be moving around a lot, so don't be surprised if in the near future, after today, if when you catch me on the next live stream or you catch another DCG 2-1 member on a live stream, do not be surprised if we're like in someone's backyard or in a living room that's completely new, or we're at like a Starbucks or a McDonald's or a bar or something, just because that's how crazy this month is going. Normalcy will resume hopefully before DEF CON 30. Oh, especially hopefully before Hope. But just want to let everyone know that that's why we haven't been streaming a lot, because for the past month and a half, myself and everyone else has been going crazy with a lot of adulting, and this is me kind of trying to get back into it while I still have time. So, what we're going to do next is, as I said, we looked at some of the news. There was a lot of fluff. Like both, I feel that the state of the platform as well as the keynote itself was fluff. They basically, it reminds me of an E3 presentation that's lukewarm, like a Microsoft presentation, where they kind of just like, they were like, here's the new M2, we're going to hope to come out with that, but we're not going to show any real concrete stuff with it. And then like, here's a bunch of operating system updates, and here's some new developer tools, buy, and there's not no like, we're making an iCar or like an Apple iDildo or something that's like tangibly new. Like it's still all the same devices and platforms. They're just adding new coats of paint, which is really disappointing, because this was really hyped up. Like there was people who noticed that the App Store was being rebooted, which hasn't happened in a million years, and stuff like that. So people were hoping there was going to be a truly a new, whether it was a hardware or software thing, but preferably a hardware thing, like a new thing from Apple. And of course, like Tim Apple usually does, he just didn't deliver with that. So without further ado, I'm going to have to be doing a more adulting for about 2 or 3 hours, but this live stream's not over yet. I will catch you guys all at the end. In fact, at the end, we might actually look at the Developer App Awards, which apparently is a thing for Apple. And what we're going to be doing is we're going to be airing, which I'm going to import over in a moment, some amazing videos about Apple hacking. So like while everyone's trying to see the WWDC, they're instead going to learn about how all of their Apple devices can get pwned and have gotten pwned. These are all full disclosure public videos. Half of them are going to be from DEF CON 29, which was DEF CON last year. I'm pretty sure this year for DEF CON 30, there's going to be even more Apple stuff. And DEF CON 31, with all the stuff Apple announced today, with all the software stuff, especially with their focus on privacy and security, I can't wait for those talks next year or even later this year at other conventions. It's gonna be interesting to see, because the M1 chip got cracked really fast. It'll be interesting to see how fast M2 and these other services get cracked. But half of them are going to be coming from DEF CON 29, and half of them are going to be coming from the Objective by the Sea conference held at the wonderful, amazing Apple hackers at Objective C. So this is just going to be like 2 to 3 hours of nothing but those videos. It's going to be topics such as red teaming, breaking the U1 chip, which is, I think, Apple's like broadcasting chip, Apple and Mac and iOS malware, privacy and security issues with iPhones and iPads and stuff. It's going to cover all sorts of things. So we're just going to air that. You're not going to see me for like 2 to 3 hours, but I hope you enjoy these amazing videos that were hosted by DEF CON, and as well as the awesome people from Objective C. So this is the part where you get to truly lurk and learn. I will be in chat, however, even though I'll be running around adulting, and hope to see you in like about an hour or 4. All right, so pay attention here. Awesome hacks about to come in. If I can just copy, pasta, import this. Okay, so here we go. We're going to be doing awesome Apple hacking videos in 3, 2, 1. See you in a couple hours.
Hey, what's up, DEF CON? This is Cedric Owens. I'm super humbled and excited to be here. And I'll be talking about basically giving a perspective of what red teaming looks like in macOS environments here in the year 2021. Some background information on myself. I'm a full-time offensive security engineer on the red team side, and I've been dedicated red teamer now for the past
Sorry
almost
about that.
5
Fixed it.
years. Prior to that, vast majority of my career has been on the blue team side, doing incident response, threat detection, threat hunting, both in the intel community and in the private sector. And so even as a full-time red teamer now, I highly value collaborating with blue team just to help uplift each other's tradecraft and move the needle forward in our organizations. I personally enjoy macOS post-exploitation as an interest area of mine, that and infrastructure automation. So whenever I do have free time, I'm typically working on projects that fit into one of those two buckets. Also, as an early 80s baby, I do enjoy 80s and 90s nostalgia, such as what you see here in the picture. Just reminds me a lot of my childhood, and it's even cooler now to see my kids playing with a lot of these same toys or watching these same shows, and it's just kind of cool to see the legacy of these things live on. I am on Twitter, handle @SedOwens, where occasionally I'll post blog posts or tools that may be of interest. So check that out if that's of interest to you. So what I plan to talk about today, first one being why do we even care about macOS, especially in a Windows-centric world? Why are we even here for this talk? Overviews of common tech environments and what the tech stacks look like in organizations that are heavy Mac users. Options for macOS payloads and post-exploitation, and a look at how the different options you pick usually will have a pro and a con associated with it. We'll also look at other attack vectors, so things in macOS environment that become attack targets that may not themselves necessarily be macOS, but you'll find them often in macOS environments. And then we'll end off talking about detection opportunities to look at from a blue team perspective. So again, first question is macOS, why do we care? And to your point, if you're asking that question, most Fortune 500 companies today are still Windows shops. And you may find there that maybe 90% of their endpoints are Windows, maybe 5 Mac, 5 like Linux or Chromebooks. But there's a sliver of companies in the San Francisco Bay Area, your Silicon Valley companies, that are basically the opposite, where you may find 80 to 90% of the endpoints being Mac, may find 5 to 10% or somewhere around there being Windows endpoints, and you may have Chromebook and Linux mixed in. So essentially it's the flip of what you see in your Fortune 500 environments. It makes it for an interesting environment to assess from an attacker's perspective, because there's often a mentality, well, if we're not an enterprise Windows shop, then we're more secure. And I can understand the line of thinking there, but it really depends on how you implement your Mac/cloud environment. In other words, if you have keys laying around or in code repos or other easy places for an attacker to find, you may find that even though you've migrated off of a Windows enterprise environment, your environment can still be easily compromised. So we'll talk about that a little bit more as we go. It is a slowly growing trend that, at least that I've been seeing, where newer companies are adopting more of a quote unquote non-Windows enterprise environment. And what I've noticed is that Active Directory is typically going to be there because it usually is the best LDAP solution for enterprises. So even in these environments, you will have Active Directory, which will be used to back your authentication, but just your typical end-to-end enterprise rollout of Windows will be different here. And I like it too because it allows, as a red teamer, it allows you to point out different vectors that really have nothing to do with Active Directory and compromising domain controllers, but other very interesting vectors that can still be impactful and in some cases devastating to your organization. So I think it's a very interesting environment from a red team perspective. So first we're going to look at common tech stacks and what you might encounter in a common tech company in a Silicon Valley area. First thing is there's a concept of realms or environments. And so you may have a corporate environment, a dev or stage environment, production environment. And so here's an example. We'll walk from left to right, where you may have employees that remote in using an identity as a service solution. Two common IDaaS solutions are Okta and OneLogin, where the employee authenticates with their username, password, and a 2FA token, which is usually going to be like a Okta Verify push or Duo push to their mobile devices. Once they log in, they're now inside of their identity as a service portal, and they have access to a lot of different productivity applications like email. You may have Atlassian products like Jira. You may have Salesforce, internal Git, even custom application servers, all accessible to the user based on their roles in Active Directory. Then you also, on the production side, you may find a combination of cloud-based production hosts and on-prem, and you may find a lot of different things there. But typically in production, you're going to find like your customer-ready code and maybe even customer data that's stored here. And you're going to find things like your build hosts, your CI/CD pipeline. You may find some cloud-hosted services and servers there. You may find HashiCorp for managing application secrets. And of course, you may have some on-prem stuff. You may have Jenkins on-prem or even in the cloud. You may have some Windows servers, segmented environment of Windows servers there. So a lot of different things going on here, and it makes it interesting because, of course, there's a lot of complexities, and sometimes with more complexities comes more opportunities from an attacker perspective. Another thing to point out is on the bottom left, I have rough percentages over the different endpoints. So like I'm showing macOS being 80% and Windows being 15 and Google Chromebooks being 5%. It's just a rough numbers there. Some organizations you may actually find Mac being higher or closer to 90% and the Windows population being even smaller. So it's interesting because with Mac being such a high percentage of endpoints in tech environments, and engineers using their Macs often to either do dev work locally on a Mac or log into like a cloud hosted server or an application server or Jumpbox from other places that they can do their development work from there. You typically may find that there are sensitive keys, tokens, credentials, things like that that are stored on the endpoint. So really end to end, this makes for a very interesting environment to assess from an attacker's perspective. Next, I'm going to talk quickly about some different ways that macOS is deployed from an enterprise perspective. One option is like custom deployment, where you hire your own team and they build out some custom solution to manage and hook into Macs and control them and push policies, etc., and basically loop back into your LDAP solution. Organizations that do that custom tend to be maybe like your big five in tech, so something like your Apple or your Facebook, Google may all be custom, where they have the money, the resources to throw at that. But typically what I find is outside of the big five, most organizations in the Silicon Valley area, most companies there tend to use a solution that they purchase, such as Jamf Pro, which is really the most common that I've encountered, but I also notice other products that are up and coming like Kanji. And so we're going to take a look at those. Also wanted to point out Caleb Hall and Luke Roberts in their Black Hat talk this year did a really good talk on abusing Jamf for remote management and how an attacker can leverage that to control and compromise managed Macs in an enterprise environment. So highly recommend checking that out. So there's a very high level overview of common Jamf deployments that you may see. You typically have an admin server. If you're in an environment that uses Jamf, you can run Jamf check JSS connection from terminal, and that will return the URL to your Jamf admin server. You also have your endpoints, which have the Jamf agent on them that receives the configurations from the admin server. You also have self-service that runs on the endpoints and allows users to install software versions that their IT department has already vetted. So essentially, they don't have to open tickets for these. They can just install them from self-service. Really nifty way of doing things. Also, Jamf does include the ability to have remote management, where admins can remote in to do screen sharing or other troubleshooting on the endpoints. And typically that is through an admin account that has SSH access into the endpoints. Oftentimes, from what I've seen in enterprise macOS environments, SSH is enabled on the endpoints, and the IT team will use an account that can SSH in, and it has sudo rights on the macOS host where they can perform administration. So that's a very common thing that I've seen in environments. And of course, one thing to be aware of is if that is how your environment is set up, it becomes very similar to the problem on the Windows side years ago about dealing with SMB and local admin passwords. and like LAPS coming out being a solution to randomize those passwords. Well, the same thing would apply here. If remote management's being used, is it a static password, or is there random passwords being used? And of course, if it's static password, then that means if you get that password, you can now access any Mac in the environment over SSH with sudo rights. And SSH has full disk access, so it bypasses privacy protection. So that could be really bad for the environment. So just something to think about there. Another aspect to look at here is if you run, as a red teamer, you run a phishing exercise and you target Jamf admins, which is usually a Active Directory group in your environment that limited people have access to, that the organization has identified to administer Jamf. And you phish them, you gain access to their Active Directory credentials, and then you use those credentials to log into the Jamf management server, Jamf admin server. And depending on your environment, like that admin server may be behind Okta where 2FA push is required, or it may not, maybe just be locally in your environment without 2FA. And you can get access that way, and then from there you can start to push policies and scripts to run on the endpoints. And really there you essentially do have full control over your Mac OS environment. So this is something, an attack path to think about as well if you're in an enterprise Mac environment. But now, even when it comes to Jamf, there's really so many different ways to implement Jamf. There's really no one way to do it. So we're just going to look at a few examples. First example is probably the simplest, where Mac OS hosts are bound directly to AD. And in that case, you can run like different DSCL or LDAP search commands to pull AD information directly from the domain controllers, just as you can on the Windows side, like for example with net user commands like that. You can do the same here. And tools such as MacHound, which is a Mac OS port of Bloodhound, or Cody Thomas's Bifrost, which does Kerberos manipulation, those tools would work and apply in this environment, since the Mac OS hosts are bound directly to Active Directory and can query them directly. Another example is access via a tool called Nomad, where in this case, Mac OS hosts are not bound directly to AD. So if you try to query Active Directory from these hosts, you won't be able to reach it directly that way. And essentially the user logs in locally with a local account, and then they do network authentication for access to resources, which is where Nomad comes in. And that Nomad then performs Kerberos authentication on their behalf. And so if this setup is how your environment is configured, then there are files that you can read from that you might find interesting on an assessment, such as like different P-lists that I have mentioned here. Also things like K-list, KCC, Cody Thomas's Bifrost tool that does Kerberos manipulation. Those tools would still work since Kerberos is still happening from your endpoint. So something to think about there. Another example, same setup or similar setup here, where your Mac OS endpoints do not have direct access to Active Directory to query domain controllers directly. In this case, they have Jamf Connect on them, and Jamf Connect is synced through Okta, and Okta does the syncing with Active Directory when it comes to authentication. And so like a federated model there. And what's interesting here is, like just in this example, the Active Directory controllers are domain controllers are walled off by like firewall rules or VPN access, maybe a specific VPN profile that you need. So again, if you try to query directly, this would not work. But if this were how your environment's set up, there still are some interesting P-lists and files on the system that you could pull from to learn more about the host and the environment that you're in, such as what's here, the two files highlighted above. So as I mentioned, AD is still present in Mac OS environments, but it just looks a little bit different from what you see in your enterprise Windows environments. And I enjoy it because it gives me a chance to focus on something else outside of Active Directory. And of course, when you're in these types of environments, they're heavy Mac and cloud implementations, so a lot of interesting things to look at. So let's talk about that. First, we're going to talk about initial access. In this case, targeting our identity as a service portal. So the two most common are Okta and OneLogin. A tool that is pretty popular here is EvilJinx 2 by Kuba Gretzky. And what it does is you point it to a target login portal. It clones that portal, and you basically send out a link to the fake portal. And as people log into the fake Okta or fake OneLogin portal, it captures the username, password, and it authenticates it to the actual site and does the same thing for your 2FA token. So then the attacker is able to grab the token for Okta or for OneLogin, import it into their browser using a plugin like Edit This Cookie, and now you're the compromised user. And what's so interesting about this attack path is once you're inside of someone's identity as a service portal, you have access to a ton of different productivity apps. So you got Slack, think about the credentials, configuration files, secrets, things that people have shared in Slack that may be pinned in different channels. Think about Gmail or Google Drive. People may email themselves passwords so they don't forget, or sensitive information. You have access to search all of that. Imagine like your Confluence, your Jira tickets, things that may have interesting data there, or Wiki, all sorts of juicy information there. And as a red teamer, you may opt to take this path and essentially meet your objectives without ever even needing to land access on a macOS endpoint. So this is definitely worth running in your environment from both a red and a blue team perspective. And one of the big wins from the blue team side is allowing, basically running through your procedures to see if you have visibility into this attack path. And if you do you have the ability to revoke compromised tokens? Because in this case, password resets are great, but if you don't revoke the compromised token, you're not going to be able to boot out the attacker. So a good way to test your detection and response procedures. So I mentioned a lot of interesting data in your productivity portals. And there are some tools that people have written to actually automate this if you're using this from a red team attack perspective. One being a colleague of mine, Antonio Piazza. He wrote a few different what I call thief tools of GD, GDIR, and Conf Thief to simulate or speed up downloading sensitive files from those platforms. Also, a colleague of mine, Brad Richardson over at Credit Karma, wrote a tool called Slackhound that does a similar thing. If you find a Slack token on a host, you just feed it and it uses API calls and things of that nature to pull down data, as well as Slack Pirate. So a lot of different and interesting attack paths on this vector. So now we talked about identity as a service briefly. I'm going to pivot over to the macOS side of the house and talk about some of the basics around macOS from a security perspective. I like to break it into three different areas: prevention, detection, and removal. Gatekeeper on the prevention side is essentially the engine that, or the I guess you say the service with syspolicy D is behind it as the engine that evaluates certain file types like application bundles and star packages, macos, etc. It looks for files that have a com.apple.quarantine attribute appended to them, which the operating system appends for any files downloaded from the internet. So if a file is of the types that Gatekeeper evaluates, such as macos, apps install, packages, etc., and it has that quarantine attribute, then Gatekeeper enforcement kicks in. It checks to see if it's signed and if it's notarized, and if not, it will block it from running. If it does, it still does a pop-up. But what's of interest here is that even for non-signed, non-notarized, like app packages, installers, Mako binaries, etc., the user can still right-click open and click through one other prompt to run it despite Gatekeeper. On the detection side, you have XProtect, which is also part of Gatekeeper, and it's really more of the malware definitions and blacklisting that I guess you can say comes from like Apple Intel, from real world malware resources or malware sources that they have analyzed. And then you have the malware removal tool, mrt.app, and that does the remediation. From a red team perspective, the prevention side of it really is the hardest hurdle to overcome. XProtect and mrt.app usually are not big factors for red teamers because we tend to write our own stuff for macOS since it's kind of a niche space. And since XProtect and mrt.app tend to look at existing samples for their intel, usually when you write your own stuff, those two aspects become less of a factor. It's just really Gatekeeper that becomes the pain and headache from a red team perspective. Other things to think about is the concept of TCC, or privacy protection. So, and that essentially you have certain folders or certain places on disk that TCC protects. So you have things like the user's desktop, documents, downloads, all sorts of other places on the system that TCC protects. What's of interest, though, are things that are not protected. So the home directory itself, and within the home directory, certain other subdirectories like a .ssh or .aws directory, both of those would contain credentials. And the ability, if they're captured, to provide lateral movement. Temp directory is also not protected, which is why malware typically is dropped there. And so just something to think about, because again, if TCC is enforced, a pop-up will show to the user where they can allow or deny if like that directory is requested. But for not protected folders, there's no notification to the user, and access is not prevented at all by TCC if it's not protected by TCC. The Evil Bit and Reggie did an excellent Black Hat talk this year on 20 different ways to bypass TCC, so definitely check that out. They'll dig way more into what TCC is and different methods for bypassing, so check that out. From an initial access perspective on Mac, a lot of different options here, and they all have different pros and cons. You have your Mako binaries, which are checked by Gatekeeper, but you typically need a delivery method because most of the time your Makos are not going to be double-click friendly. I mean, there are some tricks you can do, but just generally speaking, you'll use your Mako as a second stage payload. Apps are checked by Gatekeeper. They're pretty remote friendly because, again, they're app packages and they're double-clicked usually. And so they are remote friendly, but they are checked by Gatekeeper. Install packages are also checked and remote friendly that allow users to double click. You got weaponized PDFs, shell script trickeration, which we'll talk about later. Essentially, that is a bug that I found in Gatekeeper this year and reported to Apple and worked with them to get it fixed. You also have your scripting languages that are not checked by Gatekeeper. Things such as JXA, which is JavaScript for automation. Cody Thomas did an excellent job a couple years back of highlighting how powerful JXA is on Mac and how it's essentially like an Apple script alternative. And it's kind of interesting because sometimes I view JXA as like the replacement for Apple script, but they're both still around and they'll probably both be around for a while. Of course, Python is not checked by Gatekeeper. However, Mac or Apple will remove Python from base macOS installs at some point in the future. We don't know when, but from an attacker's perspective, it's just something to keep in mind if you're heavily relying on Python. Office macros are not checked by Gatekeeper, but it is sandbox, meaning it will be, if you gain access remotely via Office macro, you only have access to certain parts of the disk and certain binaries, etc. So a lot of different options here. Got AppleScript, browser extensions. One thing I wanted to point out was that on Mac OS, Doomfist Leopit wrote a really neat tool called Mystical that is a payload generator for several of these types of payloads where you can provide it information, it will generate the payload for you. I also wanted to point out Mythic by Cody Thomas at Spectre Ops is what I consider at this stage to be the king of macOS command and control because of its innovative use of JXA and has a lot of other cool features with how it's built and how it's managed. So definitely check that out from a red and blue perspective. Quickly going to jump into some different examples. So the first example being installer packages, and I'm going to briefly talk about script only because they're the most common and pretty simple example here. But you have a pre-install and a post-install script, and both require the shebang at the top and exit at the end in order to run successfully. They run as child processes of the installer packages, so whatever scripts you have running. And it runs elevated as root from an attacker's perspective, which is a nice plus because any installer package that a user detonates and to install, they end up authenticating. And usually in macOS environments, the user is local admin. So when they authenticate, that installs with elevated or root access on the host. As I mentioned before, it is checked. Installer packages are checked by Gatekeeper, but they can right-click and open, and that's a common technique that's used in the wild with real-world malware samples. So Patrick Wardle and Objective-C have a lot of good examples of like real-world malware samples for macOS, and you can look through their Mac malware reports of 2020 and 2019, etc., and look for different examples for how these types of things are done, like an image is included and the user is instructed to right click and press open in order to run a non-signed, non-notarized installer package. Here's an example, pre-install script. So we talked about pre-install and post-install. This is an example on the pre-install side that essentially just pulls down a unsigned, non-notarized Mako binary, writes it to the temp folder, and sets the executable bit. On the bottom is an example with us being remote these days and so many employees being from home. This is an example of how you could add a guardrail in there to check for the host name to ensure that it's not running on someone's personal machine, but on a corporate machine. If it's found to be running on a personal machine, it will exit. If not, then it will perform the pull down of the payload and set the executable bit. And here's an example of a post-install script where it just runs the Mako binary backgrounded. So once you have that set up, you can just run this package build command here to generate the package, host it, get it to the user, they detonate it, they authenticate, they basically double click and authenticate through the installation, and it detonates in the background. And as you can see at the bottom here, this is my Mythic, a screenshot of my Mythic C2 server, and the payload detonated as root level access. Another example, you have app bundles or app packages where you have the app, the name of it with contents / macOS, and then a Mako binary at the bottom. And so to do this, a very simple way, you could go into Xcode, create a new project. In my example, I'm using Swift here. And then you would design a window with buttons, icons, text, etc. for a user to interact with. Once you have that designed and ready to go, you go into info.plist for any app transport security. So app transport security are restrictions on Apple to limit the types of outbound connections that app packages can make. So if you're trying to talk out to like a non-HTTPS server, so just plain HTTP, there's certain entries you have to put in there to allow that. And even if you're talking to an SSL server, it does not like self-signed certificates. So you actually have to get a valid signed certificate for that to work. And then of course you set your sandbox accordingly, the settings there that you need, and then you can add code like here below that uses a dispatcher, and again this is Swift, as a background task to execute a JXA payload that's hosted on a server. And here's an example of the window that you could design for the user to interact with, and as you can see, it can be very convincing. And the user clicks update now, then the Mythic command and control server receives a callback from the user. So again, app packages are checked by Gatekeeper, but as you can see here, as I mentioned, same with installer packages, same with here, you can right click and open. So here's an example from the Slayer, which is a common macOS malware family that's been around for a while, of a simple image to social engineer the user into right clicking and opening to run an unsigned, non-notarized app package. Of course, you have Microsoft Office macros. They still work. They've been around for a while. And even today, I like to do tests with macros where I just will attach it and see, let the email system's antivirus filter scan it and see if it detects it as malicious. And one thing I've noticed is that simple string concatenation is usually enough to get it around those filters. So if you're taking like the word exec and doing E plus X plus E plus C, for example, that will get around a lot of the filters. We'll look at an example a little bit later for that. No gatekeeper concerns, but as I mentioned earlier, it is sandbox, meaning you have limited disk access and limited functions or binaries that are available to you. You can still access things such as like OSA script, curl, screen capture, Python, so still a lot of potential there. And Adam Chester, who's currently at TrustedSec, did a blog post a couple years back where he looked at entitlements that Office products had, and he found that they had one entitlement to drop files outside of the sandbox if the file name was prepended with a $$ sign. So really good research, and that technique still works where you can drop files on disk outside of the macOS sandbox using that technique. A colleague of mine, Madhav Bhatt, who's also at Credit Karma, he recently published a sandbox escape where essentially you create a ZSHENV file that executes a payload. You zip it, and for that zip file, you prepend the $$ sign in front of it. You drop it to the user's home directory. You add it as a login item, and then on reboot, when the user restarts, the login item extracts the zip file, drops the ZSHENV file to the user's home directory, and then when the user opens a terminal, you have non-sandbox callback to your server. So definitely check it out. A very informative blog post and does still work. Some example Office macro generators for macOS. Macfish has been around for a while, and honestly, that's where I learned. I took a lot of my cues of how to write macro generators from Macfish. It's got a lot of cool options where you can generate Office macros that use Python or curl or OSA script or combinations of them. I also wrote a couple macro generators as well for Mythic that uses curl and OSA script, and I did my own for MacC2, which is a command and control tool that I wrote for macOS that leverages Python. I did highlight Python in red because, again, Python will be eventually taken off of base macOS installs. So I like to highlight it in red so you can be prepared when that happens, which is why things like switching to JXA, for example, is a good option because that will be around for a while. Also, when it comes to Office macros, auto open subroutine is useful so that when the document is double clicked, the Office macro can be executed. And here's an example here of how I concatenated like the word Python and the word exec, and you see long strings of base64 characters, or I guess in this case hex characters, excuse me, long strings of hex characters. And what those do is, in this payload that I've written, I basically read the actual payload from a file, read it into a long hex string, and now it's just breaking that hex string into smaller chunks. So now we're going to quickly talk about CVE 2021-30657. This was the bug I reported to Apple this year that was a gatekeeper bypass around the March timeframe. And where the idea for this came from was started thinking about, well, here's the typical structure of app bundles on macOS. You have the app name, you have the contents directory, macOS directory, and then there's a Mako inside of that. So when you double click an app bundle, the Mako inside of it is what executes, and it just has all these other wrappers around it like info.plist, etc. So I started thinking, like, what if we put something else here, something that's not checked by Gatekeeper, because Makos are checked, which is why when you download an app from the internet and try to execute it, Gatekeeper will pop up, like if you just try to normally run it. But in this case, what if we put something like Bash or Python in place of the Mako binary, since neither of those scripting languages are checked by Gatekeeper? So I did that. That's kind of what led to the bug. I found that it worked and it did bypass Gatekeeper. And I reported this to Apple March, I believe, of this year, and they fixed it in short order in Big Sur 11.3 and in Catalina updates. From the Apple Security Bounty website, they have a section there for user-installed applications and access to sensitive data. $100,000, all right, really big bounty payment. But they have you see the two asterisks there next to the first line. I wanted to highlight that because Apple has a very narrow definition of what they consider sensitive data. And in my opinion, it's much more consumer focused versus enterprise focused, because they only consider contacts, mail, messages, notes, photos, or location data to be sensitive information, which makes sense from an individual consumer perspective. But when you're starting to look at Macs in an enterprise, like what we're talking about here, Mac OS environments, where organizations have thousands of users that are using Macs and they're doing development and engineering work with sensitive data on the host, this definition certainly should be expanded. And in my case, my app detonated, got remote access, and then I was able to access sensitive data, which is things like SSH keys, AWS keys, Azure, GCP keys, other files in the user's home directory, the user's shell history that contains sensitive information depending on like what they've done. So a lot of different pieces of sensitive information that this payload had access to, but because of Apple's very restricted and limited definition, kind of individual consumer focused definition of sensitive data, I received a tiny bounty payment in this case, nowhere near that 100,000 there. So just wanted to point that out for researchers, if you're submitting things to Apple, to just be aware of that. And the reality is Apple may say that this is the small breadth of sensitive data we care about, but from an attacker's perspective, like you may have a bypass and you're able to get things that are outside of that window of Apple in terms of like their definition of sensitive data. but it's still sensitive data. And so that can happen in your case as well, where you receive a small bounty payment. So just wanted to give you a heads up with that. Some interesting things about this payload. As I mentioned, it does bypass gatekeeper and app transport security that we talked about earlier, where the system restricts like what websites an app can talk to or what types of protocols it can talk over. Those things don't apply. Also, you'll have access to non-TCC folders, so you'll have the ability to grab things like SSH and AWS keys, etc., off the host. And it's very convincing. So as you can see here, just by copying icons over to my fake app, and it's got the OneDrive logo, and it looks pretty close. And so it serves as a really good payload that a user can just simply double-click a DMG or zip and double-click the app inside of it, and that's it. So it's no need to right-click and do all these other things, which made this a very powerful bypass. And in my tests, I did both with trying a shell script at the bottom of the app bundle, as well as having Python at the bottom of the app bundle. And in both cases, they worked because neither Python or Bash scripts are checked by Gatekeeper. So I was able to get a callback in both cases. And here's an example, just kind of walking you through what the payload looks like. And I'm just showing you here that that terminal does not have full disk access. It did not have any folder access as well. And Gatekeeper set to App Store, which is the most restrictive level. So just wanted to show that there's no trickeration going on in the background. Here is the payload that pulls down curl, or uses curl to pull down the payload and runs it backgrounded. And then there's an OSA script message there, which is a fake prompt to the user saying, thank you for installing this app. So you'll see what that looks like a little bit later. Next, I'm using this masquerade script. It's a slightly modified version of a tool called Appify that's been out for years, that basically took shell scripts and put them in the bottom of an app bundle structure. And so that's what I did here, just ran that masquerade script and created a fake app that has the structure of an app, but instead of a Mako, it has the shell script downloader at the bottom of the bundle. Now what I'm doing is taking the icon from OneDrive and I'm copying it over to remove the default logo in my fake app to make it look a little bit more realistic. And notice that the operating system labels both of them as apps, even though in my case, I don't even have an info.plist there. It just kind of follows the app bundle structure. So now that I have my fake app with the logo, what I'm doing now is copying it over to a folder, and then I'm going to go into disk utility and essentially create a DMG file to host the app. So that's kind of what I'm doing here. I just moved the fake app over to a folder called hosting, and now I'm saving it there, and I'm going to give it a new name called real app. So it'll be saved as realapp.dmg. So that's what's happening here. So now that that's done, you'll see realapp.dmg was dropped there. So the next step will be to show that when a user, basically to simulate a user downloading it from the web. So I'm going to host the realapp.dmg to a local web server here using simple HTTP server. And that way I can click it, download it, and when I download it, it will have the same quarantine attribute that a user would have if they had to download it, like as part of a phishing exercise, for example. So I just hosted it. Here's me accessing it here locally. And you can see there's realapp.dmg. So just single click it, it downloads to the downloads folder. And now we'll just confirm that the DMG file does have the quarantine attribute that Gatekeeper checks. We'll take a look at that now. And as you can see, it does have the COM Apple quarantine attribute appended to it. So now we're ready to take that file that we just downloaded and detonate it and see what happens. So you detonate the DMG, and inside the DMG is the fake app that we created here in the demo. We double click that. Notice no Gatekeeper pop-ups anywhere. And as you can see, you got the fake pop-up there that says, thank you for installing this provisioner. It fakes to be from the IT team. And in the background, I get a callback from my Mythic command and control server. So again, Apple has fixed this, but I just wanted to show you what the bypass looked like when I submitted it to them. Other things to keep in mind from TCC, a lot of this we've already talked about of what's not protected. Another thing to mention is SSH is often kind of touched on it earlier, but in enterprise macOS environments, SSH is usually running by default on the endpoints. And SSH daemon, it was recently pointed out in the Mac security community that the SSH daemon actually has full disk access. So if you're on a machine and you have credentials of the user and you SSH in locally, using that set of credentials, you now can have full disk access and bypass TCC. So something to point out there. The quarantine attribute, using curl does not append the quarantine attribute. Just downloading through browsers or through like Bluetooth, like sharing files from one machine to the next, which is AirDrop. Things like that will append it, but using curl does not. So that's something to keep in mind because I use that in my gatekeeper bypass. And from signing and notarization perspective, you could totally sign and notarize your payload if you want in order to get around some of the controls. But in my personal experience, I found that it was pretty painful process. And when I did sign and notarize my Red Team payload, I had about a week before Apple retroactively found it and deactivated the developer account and revoked the certificate. So it's just something to think about. I personally believe it's probably not worth the time since real world malware samples are often using unsigned, non-notarized payloads and social engineering the right-click open execution of the payload. Once you're on a host, lots of different things you can do. You can grab the system credentials from the host. So like AWS credentials, GCP, Azure credentials. You can look through users' bash history. You look for maybe sensitive files on the system. Sometimes users might save tokens or passwords to a file. Mango PDF did a really good blog post on cookie crimes, things you can do there with for Google Chrome. So definitely check that out. I have a link in the resources section later to that blog post. Of course, you can prompt the user for credentials. You can do it via OSA script, or you can do it programmatically to not leave any command line artifacts. You can also search for other interesting files on the host, and even this file here on the bottom, this login data Chrome database contains a stats table, and that stats table contains the username and the login URL for various sites. And it's of course it's unencrypted, and you do not need root to read it, and it's not protected by TCC, meaning any non-sandbox payload can now read from that table, which means if you already have the user's password, considering oftentimes passwords are reused, that table now provides usernames to try that password against for different sites. Also, if you have root access, you can grab the keychain database and take it offline using forensic tools like Chainbreaker. And so you can gain root access via either install or package, which we talked about, that gives you root access because the user authenticates. Or if you get normal user access, you can basically prompt the user for credentials. And once you get those credentials, you can then, through tools like Mythic, you can run elevated commands since the user, if you have the username and password, that user is usually root on their Mac. So then you can use that to run elevated commands and pull off the keychain. So something to look at as well. When it comes to persistence, lots of different options beyond just launch agents and launch daemons, which are probably the most popular for macOS. The EvilBit did a really good long-running blog post titled Beyond Good Old Launch Agents, which it's like the Mac version of Beyond Good Old Run Key on the Windows side, and looks at all sorts of interesting persistence options on macOS. Leo Pitt or Doomfist also has a persistent JXA repo looking at JXA implementations of a lot of the techniques that the EvilBit talks about in his blog post. I also then took a subset of Doomfist persistent JXA and did some Swift implementations. So I have a repo now called Persistent Swift. So you have a lot of different resources there to play with, different to look into different persistence options and different implementations for macOS. Lots of other options here like Vim plugin persistence, SSHRC persistence, profile persistence. Zorier, Chris Ross, he has a really cool authorization plugin that he did a lot of research there. So a lot of different options to look into for persistence. So some other attack vectors beyond Mac that you'll typically will see in a macOS environment, one being the build pipeline, or also known as the CI/CD pipeline. And the way I like to describe it is this is the process that like an initial concept for code goes through from like the initial draft thought or concept all the way through to being customer ready. And it hits various stages and checks along the way. And what makes this so interesting is there's a lot of interconnections here across different hosts. So if you can access one of these hosts, chances are you'll get a lot of access. And sometimes your build environment, your CI/CD process will traverse environments depending on what you have implemented in your organization. And as I mentioned, a lot of integrations, like there may be some internal Git integration. And of course, internal Git becomes a target internally because there tends to be more trust for your internal Git than your external Git, meaning that since it's internal, people may feel like posting or committing secrets in your code is not as damaging. But ironically, that's going to be one of the first places an attacker will look in a tech environment, is looking through Git repos. Jenkins is often commonly part of the build process and is usually misconfigured in some way that will allow easy access. And oftentimes Jenkins will contain a lot of different secrets on it, given its role in the environment. And then of course you have workstations where engineers may be doing development from their Macs, and they have local keys stored there as well. Quick look at Jenkins, two common misconfigurations. This is the first one, allowing unauthenticated build jobs to be executed. So if this is present in your environment, you can hit the view default new job URL in your Jenkins host, and it will bring you to a page that will allow you to run a new build job, where then you can add a single step to execute a shell. And you put whatever shell command you want in there. It could be like running a remote shell, reverse shell payload. It could be catting out files on a system that are sensitive. It could be querying for metadata service IAM credentials if your Jenkins host is in a cloud environment. And so you execute it and you can see the console output there. So essentially this will allow compromise and access to secrets, which can then be used to pivot to other parts of the environment. Another misconfiguration for Jenkins that's pretty common is the script console page allowing unauthenticated access. So if this is configured in your environment, you can just hit the script page of your Jenkins console, Jenkins host. You'll be brought to the console, and then here you can run Groovy script and essentially get like reverse shell access. You can cat local files, query for IAM metadata credentials in the metadata service. So all sorts of different things you can do here as well. A few other juicy targets. Of course, internal wiki, so thinking about like all the organizational information, system environment information, credentials that are there that can be leveraged by an attacker. Thinking about your internal ticketing system, like imagine the environment information that can be learned there, or processes and architecture information. Slack, of course, we mentioned that earlier. Credentials, keys, VPN profiles, all that stuff can be found oftentimes in Slack. Another one, if you have Docker in your environment, if Docker's configured with unauthenticated API sockets, then those hosts can be hit on port 2375 or 2376, usually default ports. But those hosts can be hit and shell commands can be run unauthenticated on those and potentially extract secrets out from your containers there. Of course, we talked about internal Git. So a lot of different juicy targets once you're in a macOS environment outside of just macOS. And of course, you have cloud hosted. Usually if you're in a macOS environment, there's going to be a good amount of cloud there as well. And so the entry points for cloud keys oftentimes can be phishing payloads, like grabbing cloud keys off a compromised endpoint, maybe code internal repos for your internal Git. So like finding secrets that have been committed there. Of course, your build hosts, like your Jenkins as an example. Sometimes even build logs will write the cloud keys that it used during the build. So that's a misconfiguration to check for as well. And it's good, I think, to also test from a blue team perspective to see what your cloud visibility and detection posture is. So can blue team see things like accessing secrets in the environment and using those secrets to pivot, like different post-exploitation examples, like on the AWS side, like looking at secrets manager or parameter store for additional credentials, which may provide access to like another environment or a higher level of access, assuming into other roles. So maybe like an attack, let's say red team has access to an AWS role. That role has the ability to assume into another role the role that they can assume into has higher privileges. So that would be a form of privilege escalation or lateral movement to see if like blue team can see that, attaching policies to users or roles, all sorts of different things here that can be done. And I think it's worth like running through these types of scenarios proactively, or even looking at the MITRE attack matrix for the cloud that they have, and looking at some common like privilege escalation and lateral movement techniques for different cloud environments. So other recommendations on the blue team side is I definitely recommend leveraging the Apple Endpoint Security Framework. It's good both from a personal standpoint. So let's say you have a payload, a red team or a real malware sample payload, you want to understand what it does. You can take Patrick Wardle's process monitor or file monitor that he wrote, and you can take it on a sandbox Mac OS system, detonate it, and then you can look at the Endpoint Security Framework logs. It's almost like the equivalent of a sysmon for Apple or for Mac OS. So definitely check that out. And then you can look for things like suspicious command line executions, persistence methodologies. We talked about repos that you can use there, parent-child relationships. So things like an Office document spawning binsh, for example, that would be something to key in on. Of course, network detection. So looking for one host accessing one or many ports on multiple hosts over a short period of time might indicate like scanning or sweeping activity. Of course, identity as a service abuse. We talked about Okta One Login. So being able to see if you have the ability to see compromised tokens, and if so, do you have the ability and procedures in place to revoke those tokens? Of course, Jenkins abuse. So getting visibility into script console abuse or build jobs running suspicious shell commands. And then within cloud itself, like AWS or GCP, for example, looking at your common post-exploitation and privilege escalation methods and auditing. You could even proactively audit your roles and see what, like you can work with, I guess, if you have a cloud security team, you all can work together to see what the state of your current IAM roles are, what roles they can assume into, and look for like easy privilege escalation paths and see what can be done to reduce those paths. Lots of different resources here. Lots of cool people have done a lot of awesome work in the macOS space. So this is not all inclusive, but just wanted to shout out some good resources for people who are interested in delving more into these topics. Definitely check those out. So thank you all for listening. Appreciate it. And if you have any questions, feel free to reach out.
Aloha and welcome to Bundles of Joy, a talk about breaking macOS via subverted application bundles. My name is Patrick Wardle. I am the creator of the Mac Security Tool Suite and security website, Objective-C. Also the organizer of the Mac Security Conference, Objective by the C, and also the author of the Art of Mac Malware Analysis book. So today we're going to be talking about an interesting flaw that affected all recent versions of macOS. We're going to start by looking at various anti-infection mechanisms that the flaw was able to sidestep. We'll then dive into the flaw, looking at its root cause analysis. We'll then talk about the discovery of it being exploited as zero-day in the wild to distribute malware. We'll then dive into protections and detection mechanisms that we deployed while awaiting Apple's patch. And then finally, we'll wrap up by analyzing Apple's patch to see how they ultimately addressed, fixed, patched the flaw. So first, some background. The main way that Mac users are become infected with malware, is via user-assisted techniques. These are methods that require user-assistant user interactions. I'm sure many of us here are familiar with these, but a brief review. We've probably all heard about malicious websites that display pop-ups, for example, claiming your Flash player is out of date. If you download and run what you believe is perhaps a required Flash update, your system may become infected with malware. Adversaries also do things like, poison search results, infect popular websites that users may browse to in order to distribute malware. Finally, hackers are very fond of pirating applications, but then injecting malicious code, trojanizing these applications So when users download and run them, they will be infected with malware. But really the main takeaway that kind of ties all these approaches together is there is explicit user interaction required. And in some sense, the user is ultimately infecting themselves. Now, Macs become ever more popular, ever more prevalent, so do these attacks, right? There's just more Mac malware and adware than ever. And Apple rightfully realized that, as we just mentioned, the majority of ways that Macs were getting infected was by, user-assisted, user interaction-based malware attacks and infection vectors. They really decided we need to do something to protect the users from themselves. And, I'm a critic of Apple, but in this case, yeah, I think that was definitely the right approach. So we're briefly going to look at three technologies, three anti-infection mechanisms: file quarantine, gatekeeper, and notarization requirements. As I noted, these are all aimed at protecting the user from infecting themselves. The goal is, if the user is tricked or coerced into running something, the operating system will first intercept that launch, that application launch, that process execution, and examine it to make sure that it's not malware. Now we first need to talk about the quarantine attribute. The quarantine attribute is something that is added to most, essentially all, downloaded items, either by the application that's downloading it, for example, the browser, or the operating system. And it is an extended attribute that basically tells the operating system, hey, this item is from the internet. When the user then goes to launch the item, for example, launch the application that they just downloaded, the operating system will see if the quarantine attribute has been added. And if so, it will then perform a variety of checks, gatekeeper, notarization, file quarantine checks on that item. So the quarantine attribute is kind of the catalyst for those checks. You can examine if a file has a quarantine attribute via the xadder command. As you can see on the slide, downloaded some malware from the internet, and as expected, the browser and the operating system slapped that quarantine attribute on the item. So if we were to go launch this application, the operating system would perform all its anti-infection mechanisms, its checks. So the first anti-infection mechanism that Apple introduced was all the way back in 2007. Yeah, way back. And this technology is named file quarantine. And in a nutshell, it basically will display a prompt to the user saying two things. First, hey, the item you're about to launch is from the internet. And two, it is an executable application. This is important because a large number of malware will attempt to masquerade as benign file types. On the slide, we have an example. This is Wintail that was distributed as a malicious application, but used a application icon to masquerade as a PowerPoint document. The idea from the malware author's point of view is the users might be tricked into launching this because they thought it was a benign PowerPoint application. However, file quarantine would jump in the way and say, hey, wait a minute, user, just to make you aware of this, just to make sure you know that this is actually an application, and if you run it, you might infect yourself. So a good warning, but the problem, as is the case with most warnings, users would simply click allow, open, thus still infecting themselves. So Apple had to, take the next step, and that next step was Gatekeeper, which was introduced in 2012. In a nutshell, Gatekeeper will block unsigned applications from running. Basically, when the user launches an item that they've downloaded from the internet, the operating system will intercept that, and Gatekeeper will check to see if it's validly signed. If it's not, it will block that. That was a good approach because at the time, the majority of Mac malware was unsigned. Of course, the shortcoming was that malware authors simply began signing their malware. It's pretty easy to fraudulently obtain or steal a legitimate code signing developer ID, which would then allow you to sign your malware, which would then allow you to, bypass or sidestep Gatekeeper. So Apple had to respond yet again, which they did in 2019 with the introduction of notarization. Notarization will block any application that has not been explicitly verified, scanned, and approved by Apple proper. So on the slide, we see kind of a conceptual overview. Imagine you're a developer creating an application. You compile it. You now have to submit that application to Apple, where they will scan and verify the application. If they don't detect any malicious code, they will then give it their stamp of approval. They will then notarize this. At runtime then, when you distribute this now notarized application, it will be allowed to run. The idea is malware authors will either not submit their applications to Apple for verification, or if they do, Apple will detect that they contain malicious code and thus not notarize them. This means that even then, if the malware authors successfully trick the users into attempting to run their malicious code, the operating system will be like, oh, wait a minute, this is not notarized, I will block it. And in reality, this does work very well. We can see on the slide some hackers slid into my DMs bemoaning the fact that notarization had essentially ruined their entire operation. Let's now talk about an interesting flaw, though, that was able to very neatly sidestep, fully bypass all of these anti-infection mechanisms. And as it was a logic flaw, did so in a 100% reliable manner. First, I want to give credit to Cedric Owens, who uncovered this vulnerability. He wasn't 100% sure on the root cause, so pinged me describing what he had found. We have a nice proof of concept on the slide that demonstrates the power of the vulnerability and aligns to what Cedric observed, which was we can download a malicious application from the internet that is not signed, not notarized. We can, masquerade as, for example, a resume, a PDF document, or really anything else. And when launched, neither file quarantine nor gatekeeper nor the operating system's notarization checks appear to come into play. And as Cedric notes, no prompts from the operating system at all. This is a very powerful vulnerability because what it means is, in theory, malware authors could go back to their old tricks of basically infecting users across the globe and not have to worry about any of macOS's recent anti-infection mechanisms. So let's take a look at what's going on. So we have this proof of concept, and the first thing I wanted to check was the quarantine attribute being correctly set? Because as we mentioned before, the quarantine attribute is the indicator that tells the operating system to perform its various anti-infection checks, quarantine, file quarantine, notarization, and a gatekeeper. Well, as we can see, the proof of concept is not signed, which also means it's not notarized, but indeed it does have the quarantine attribute set. We can confirm that via the xadder command. So this immediately shows us it's not an issue with the quarantine attribute being misset. But this is almost more intriguing, right? We have an unsigned application that can bypass file quarantine, gatekeeper, and notarization requirements. How? It's insane. So, closer look. What's going on? Well, if we look at the contents of the application, we notice two very interesting things. And I'll point these out because you might not be super familiar with application bundles. The first thing is, if we look at an application, .app, which is really a special directory structure, we see that it only contains three things: a contents directory, a macOS subdirectory in that contents directory, and then a file named POC in that macOS subdirectory. Now, if you're familiar with normal application bundles, you'll be like, wait a minute, where is the info.plist file? The info.plist file is a metadata file that describes information about the application, and it is always present in normal applications. I thought it was required, but apparently not. The other interesting thing about this proof of concept application is that the main executable component, named POC, was not a Mach-O executable, which is the standard executable file format on macOS, but rather a POSIX shell script, a bash script. Now, rather interestingly, there is a popular developer script on GitHub that will package up applications in exactly this manner. The idea is if you have a script that you want to, distribute to Mac users, if you package it up as an application, it's way easier to both distribute and for users to run. They can just double click on it and the operating system will take care of it. The sad or laughable thing about all of this is this Appify developer script would actually package up applications in this manner, which inadvertently would trigger this same flaw. So if you're looking for bugs in macOS, sometimes all you have to do is use open source developer packaging tools. Insane. Okay, so we have this bare-boned script-based application, right? No info.plist file, and its main executable component is a script. And we'll see these are both prerequisites for triggering the flaw. As we also saw in that proof of concept, when we download and run it, there are no prompts, as there should be, because the quarantine attribute has been set and this malicious proof of concept application is unsigned from the internet, non-notarized. So there's some flaw in the operating system. My interest was piqued. I wanted to figure out exactly what was going on. Where was the flaw? The problem, though, was that when you launch an application, when you double-click an application, there is no less than half a dozen applications, system daemons, and the kernel, which all get involved with parsing, launching, classifying the application. It's incredible. I gave a talk about this at ShmooCon a while back, talking about another gatekeeper flaw, but you can see there is a myriad of apps and daemons and frameworks that are all working together. And again, this is problematic because the flaw is somewhere in here. But this is a lot going on. Where do we even begin? So my idea was, I'm going to start by looking at log messages to see if there is some interesting log message that could point me at least towards the right application daemon, framework, or kernel code where this vulnerability might lie. And what I decided to do was launch 3 applications and basically diff their log messages to hopefully point me in the right direction of this flaw. So the 3 apps were all from the internet, all unsigned. The first one was a standard application, meaning its executable was a mock-O executable. It also had the common info.plist file in its application bundle. Second application was a script-based application, so its executable component was a bash script, but it still had that info.plist file. And then finally, we had our proof of concept, which is script-based, but is also missing the info.plist file. Now, before we can look at the log messages, we have to enable private logging. Recent versions of macOS suppress a lot of information from the logs, which is not helpful when we are digging into the internals of the operating system in an attempt to find a flaw. Long story short, we can install a profile which turns on private logging. Posted a link in the slides if you're interested in this. But once this is installed, all data will be logged, which is great. So now let's run the 3 apps and basically diff their log output. Starting with the standard application, the mock-O-based application that contains the info.plist file. 2 things pop out. First and foremost, we can quickly identify that the syspolicy-D binary, the syspolicy daemon, is the component of the operating system that is ultimately responsible for evaluating and classifying applications, binaries from the internet, ultimately saying should they be allowed or not. It is the arbiter. So we can assume, and as we'll see, correctly assume that this binary is where the logic flaw resided. There's a lot of interesting log messages here. I've highlighted what I think is the most indicative, and that is the results of the GK or gatekeeper check. And we can see there's a variety of numbers, the path of the item. But interestingly, at the bottom it says GK eval was allowed, 0, false, show prompt 1, and then a log message saying the prompt was shown. This is what we expected, as this is an unsigned application from the internet. So the log messages correspond to what we see. That is a prompt being shown to the user saying this application is not allowed. We execute the second application. This is the script-based application with the info.plist file still. We see almost the exact same log messages. However, there is an addition of a script evaluation log message, which indicates there is another code path to handle applications that contain a script as their executable component. And we'll see this is important as well. Finally, we execute our proof of concept, the bare bones script-based application without the info.plist file. You see it goes down the same script-based evaluation code path, and also the scan results are printed. Interestingly, though, there is no messages about the app being blocked nor a prompt being shown, which is also what we saw when we launched the proof of concept. It was not blocked. There was no alerts, no prompts. So now let's kind of diff these three log messages and really point out the very subtle but very indicative differences. So the only differences are actually in the scan results, specifically in the GK evaluate scan result message. For the applications that contain the info.plist file, we can see an evaluation result of 0. Whereas for our bare-boned script-based application that did not have the info.plist file, we can see that the scan result was a 2. Also, as we can see in the log message, the system identified it as not a bundle. So to summarize, an evaluation type of 0 will result in a prompt in the application being blocked, whereas an evaluation type of 2 will be allowed with no prompts. Interesting. So now let's look into both how and why this type 2 is returned and ultimately what it means. I just mentioned it actually means that the application will be allowed. At least we saw that through our experiments. So now let's look at the code to confirm that this is really the case. So we're going to reverse engineer syspolicy_d. Again, this is the daemon that's responsible for making the decisions about whether an application should be allowed or blocked. If we reverse engineer the evaluate scan result method, we can see that it explicitly checks the evaluation type. And if the evaluation type is set to 2, it does two things. First, it invokes a setAllow method to set something to be allowed. This is a flag saying, yeah, this item is allowed. And then it returns, skipping all the logic that would present the prompt to the user and block the application. Now we can see this in the static analysis of the binary, right, in the disassembly, but we can also confirm this in a debugger. So I was debugging the syspolicy daemon, set some breakpoints, and we can see that after this code has executed on our proof of concept application, which is allowed, we can print out the value of the allowed instance variable and see it set to true. We can also print out the value of the would prompt flag and see that it's no, which means, as we saw, our application is allowed with no prompts. So we've confirmed that what we saw experimentally is realized in code, but I still wanted to know, why was this evaluation of type 2 assigned to our proof of concept? Clearly incorrectly. So where does it come from? What returns it? Well, if we look back in the code, still in syspolicy_d, we see a method named determineGatekeeperEvaluation type for target. And there are various methods that are called upon the application bundle that's about to be launched. For example, our proof of concept. So first is a method, isUserApproved. And since we're not yet approved, code executes into this if statement. So we continue within it. There's then another method that's called, which is isScript. Since our proof of concept application is a script-based application, this method returns true, meaning we then go again into the next code block within that if statement. We then see two things happen. First, we see the R15 register set to the evaluation type of 2. Okay, cool, this is what we're looking for. And then we see a third method call to a method called isBundled. And if that returns false, it exits. Now, as we can see in the debugger prompt, this method returns no or false for our proof of concept application, which means we're going to jump to that leave label. If we look at what that leave label does, it simply moves the R15 register into the RAX register and then returns that. So now we understand where that evaluation type 2 is being set, and it looks like it's being returned because of our application not being classified as a bundle, which is strange, but let's look into that a little deeper. So first we take a peek at this isBundled method. All it does is returns the isBundled instance variable flag. So that's not really that helpful. But what we can do is we can look back in the code to figure out where this instance variable, where this flag is set. So we find that within a method named evaluateCodeForUser. And specifically what it does is it calls an unnamed subroutine passing in the path of the application that's about to be launched, for example, our proof of concept application. And then the return value from that unnamed subroutine is passed to the setIsBundled method, which sets or updates the isBundled instance variable flag. So obviously we're interested in that unnamed subroutine because that is the one that is ultimately classifying the item as a bundle or not, which will then determine if the evaluation type is set to 2 or not. So it turns out this unnamed subroutine is fairly straightforward. It's, as I mentioned, attempting to determine if something is either a bundle or not. And as we can see on the slide, the way it does this is looking for an info.plist file. Now, as I said about 20 times already, our proof of concept application is missing or does not have this info.plist file. The application is still allowed to run even though it doesn't have this file. However, the classification logic here thinks that that is indicative of a bundle. So if an item does not have an info.plist file, it is not classified as a bundle, which we saw was problematic. We can confirm this in a debugger by stepping over this code and then looking at the value of the isBundled instance variable, the flag. And we can see that, in fact, it is set to no, to false. So the system has basically said, you don't have an info.plist file, you are not a bundle. And this is, as I mentioned, problematic because if you don't have an info.plist file and you have an executable that is a script, you will be classified as not a bundle. Your evaluation type will be set to 2, which will then, as we saw, skip all the logic that deals with prompting and blocking the application. So we have just neatly sidestepped gatekeeper, notarization requirements, and file quarantine. Now, that's a pretty brief overview of reverse engineering syspolicy-D. If you're interested in more of the details of that reverse engineering effort, check out the detailed blog post that I posted on the slide. All right, so now we know the cause of the vulnerability. Just to iterate, script-based application with no info.plist file will get misclassified as not being a bundle and will be allowed to run bypassing all of Apple's anti-infection mechanisms. Sweet. So next up was me thinking, hey, is it possible that attackers have independently found this same vulnerability and are actively exploiting it in the wild? So the search was pretty simple. Basically, we looked for an application that does not have an info.plist file whose executable component is a script. And I pinged my former colleagues at Jamf and asked them to poke around and see if they could uncover any applications that matched this search criteria. And they actually came back and said, hey, we have an application that seems to match what you requested. So they sent me kindly the candidate application, an application named 1302.app. And as we can see on the slide, if we look at its application bundle contents, we can see that indeed it is missing an info.plist file. And moreover, its executable content is a script. Moreover, it is also unsigned and unnotarized. So this seems to be a very promising candidate. Popped into a virtual machine and executed this. Even though it had the file quarantine bit set and gatekeeper notarization, everything else was enabled, as it is by default on macOS. The application was allowed to run without any prompts. And as we can see in the output from the process monitor, not only was it allowed to execute, it was able to reach out and download and install its second stage payload, which installed a bunch of malware and adware on the infected machine. Yikes. Ping Jamf, and we were able to uncover the initial infection vector. Turns out attackers had targeted popular Google search queries and poisoned the results, and also infected sites that would show up in these results to serve up malware. So for example, if you Googled Alexa and Disney, clicked on the second link, it would take you to a site that would serve up an application that exploited this vulnerability. Jamf published a lot more information on this, so if you're interested, check out their post on that. But again, takeaway here is that this application exploited the same flaw. So if the user clicked and launched it, none of Apple's anti-infection mechanisms would even come into play. That sucks. So while awaiting a patch from Apple, I thought it'd be interesting to dig into methods of protecting Mac users. And my idea was pretty simple. First, the observation is none of these applications that are exploiting this vulnerability are going to be notarized. So why don't I simply detect and block the execution of any downloaded code that has not been notarized? Again, while waiting for an official patch from Apple. So I thought I could do this in, basically 4 steps. First, detect whenever a new process was launched. Secondly, once I detected this process was launched, classify it as coming from the internet and being launched from the user. This was important because, I wanted local items to be able to run, and also if there was something that was already installed, downloading updates, I didn't want to get in the way. So I basically said, I only want to focus on applications that are from the internet that the user has launched. And then because macOS has this flaw and we can't rely on its anti-infection checks and its notarization logic, can we then explicitly check if that item is notarized, meaning it's been scanned and approved by Apple, which this malware obviously won't be. And if it's not notarized, simply block it. Turns out this was actually pretty easy to do. So first, we can leverage Apple's endpoint security framework, the ESF. And this is a really powerful user mode framework that allows us to register for operating system events such as process launches. So here's a snippet of the code on the slide. We can see we're registering a new endpoint security client, and we're telling it we're interested in the event auth-exec. The auth-exec event tells the operating system, hey, please invoke my callback anytime a process is about to be launched, and I will tell you if it's authorized or not. So it allows you to be the arbiter. I've blogged more about the endpoint security framework, posted a link on the slide if you are interested. Okay, so now we have a callback that's going to be invoked by the operating system every time a new process is launched. So the first thing we want to do is we want to check if this is an item, for example, an application that the user has launched from the internet. And there's a variety of ways to do this, but the easiest way is simply to check its app translocation status. App translocation is another security mechanism built into macOS that was in direct response to research I published and presented at DEF CON 15, which involved dilib hijack attacks. The idea is when the user downloads something from the internet and launches it, Apple takes just the application bundle, copies it to a randomized read-only share mount, and executes it from there. So no external libraries can be, injected or hijacked into it. It's a pretty good security mechanism. So what we can do though is when an application is launched, we can query and see, hey, was it translocated? And if the answer is yes, we know A, it's from the internet, and B, it was launched from the user. Cool, which is exactly what we want to know. Unfortunately, there's no public APIs to do this, but there's a very powerful private API. SecTranslate is translocated URL that you just invoke it with a path, and it will give you a result whether that item is translocated or not. So we can leverage that. It's perfect for our needs. And then finally, we need to see if this user-launched application from the internet is notarized or not. Apple provides a public API to do it, the Static Code Check Validity API. You can invoke this API with a requirement. So what we do is we initialize a notarization requirement and then make this API call, and it will set a flag whether the item we're examining is notarized or not. So if we put this all together, and I did within an application I wrote called BlockBlock, it's fully open source, it's available on GitHub, we can now generically prevent the execution of applications, even ones exploiting this vulnerability as a 0-day. So there's a screenshot on the slide. We double-clicked this executable, this malicious 1302 application that was exploiting the vulnerability as a 0-day. The system intercepts the application launch. Because we've registered with the Endpoint Security Framework, invokes our callback. We see this item has been app translocated because the user is launching it and it's from the internet. We check and see that it's not notarized. We then alert the user saying, hey, just to let you know, blah, 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 and essentially blocking the execution of the exploit. Hooray, this is great. So we have a pretty good way to protect against this, again, while awaiting a patch from Cupertino. But I also wanted to figure out, was there an easy way for us to examine a system to ascertain, to determine had it been infected or not? Answer the question, was I exploited? So I kept analyzing syspolicyd and looking at the log messages, and there was an interesting log message that we can see on the slide. Basically says updating flags, and then has the path to the item that was analyzed, was classified, and then a number. And so what syspolicyd does, we mentioned it's the arbiter, it's the one making the decisions about whether an application should be allowed or blocked. And then apparently looks like it saves or logs out the results of this statement. So I then ran a file monitor, FS usage, while executing the proof of concept and various other applications. And I could see that once syspolicyd had classified the application either as should be blocked or inadvertently should be allowed, or legitimately should be allowed if it was a legitimately notarized application, it would update an undocumented database called exec policy. On the slide, there's a screenshot of the database. We can see there is a volume UUID, something that says object ID, FS name, and then also things like the flags, basically the result of the evaluation from syspolicyd. So hooray, we have this undocumented database where syspolicyd is writing out the results of its evaluations for everything that the user launches. This seems like a good path to go down. Unfortunately, looking at the values in this table, there's nothing that immediately pops out that points to the path of the item that was run, which is ultimately what we want, right? We want to know, hey, was I exploited, and where's the item that triggered, where's the malicious application, right? Well, it turns out that object ID value in this undocumented exec policy database is actually a inode, a file inode. And we can confirm that. We can see on the slide, we take the value, the one that starts with 23D, and if we execute the stat command on the proof of concept application that I downloaded, it matches. We can then also take that path, query the database, that inode ID, and we can see that it does appear to be the same application. So what I then did is I needed to figure out a way to parse all the rows in that database, in that specific table, and then for each of those, take the volume ID and the file node ID, and then from that, get a full path to the item. And yes, you can do that via the stat command, but that's really rather slow. Well, turns out there is a foundation API you can invoke, get resource value for a key, that given a path that starts with .volume and then the file inode will actually return to you the canonical path of the item. So it's kind of a mapping of file node to path, which is exactly what we want. So I implemented this in a basic Python script. The link to the Python script is on the slide. Pretty simple. It basically parses this undocumented exec policy database And for each item in that table, it first resolves the path from the file inode, and then it also checks for if the item is an application that is missing an application, an info.plist file, and whose executable is a script. So in other words, it's basically just looking for these bare bones script-based applications. No info.plist file, executable is a script. And this is important because in this database, there's a lot of other legitimate items, standalone scripts, legitimate applications that have been run. So it's important to kind of filter out those results. I ran this then on a system where I had run the malicious application, and we can see that the Python script was able to identify and pull it up. So that's kind of cool. Apple did finally release a patch. So let's end by kind of looking at their patch, reverse engineering it to figure out how they ultimately fixed this flaw. So the patch was released in macOS 10.13 and was assigned CVE 2021-3657. Again, giving credit to Cedric Owens for ultimately uncovering and reporting this lovely vulnerability to Apple. So when you usually look for what was changed in a patch, if you know the specific details about the vulnerability, it's a lot simpler. So we don't have to diff the entire patch. We know we can actually just diff the updated syspolicyd. And moreover, since we identified the root cause of the vulnerability, we can assume that that's where the patch details ultimately lie. So we can start there and confirm whether our assumptions are valid, are correct. So recall the crux of the flaw was the misclassification of an application bundle, one that was missing an info.plist. And this was realized in an unknown subroutine in the syspolicyd daemon. So what I did was I diffed that subroutine of an unpatched system and a patched system. And as we can see on the slide, the unpatched code had 26 unique control code blocks, whereas almost 10 more had been added in the patched system. So this is a really good sign that the majority of the patch was within this subroutine. So we'll start our reverse engineering there. If we analyze the updated syspolicyd, specifically this unnamed subroutine that has the isBundle algorithm, we can see that the classification algorithm has been greatly improved and expanded. Specifically, there was the addition of 2 new comprehensive checks. The first is checking if the item's path extension is app.app. This is important because if an item is not named .app, when the user double clicks it, it's likely not to be launched by Finder. So this is almost a prerequisite to get an application to be launched. So it makes sense to check for this, right? So if we look at the disassembly and also the pseudocode, we can see it's basically just getting the path extension and then checking if that path extension is app for application. If it is, it then classifies that item as a bundle. Check 2 is it also checks if the item contains content/macOS. So even if it doesn't have that .app extension, it looks for this directory structure. Again, this is a very important check because this is required. Info.plist file is apparently optional, but this directory structure is what defines an application bundle structure. So again, we can see the disassembly and then the decompilation at the bottom. It's essentially building this path and checking if the bundle contains that. And if the item does contain that, it now says, yes, you are a bundle. So in summary, the patch added 2 checks. First, it checks if the item has an application file extension. And then secondly, it also checks that it contains content/macOS. And if either of these conditions are true, it says, yes, you are a bundle. So with this new algorithm, with this improved isBundle check, this algorithm, if we run the proof of concept vulnerability application, we can see that macOS now correctly classifies it as a bundle, which means its evaluation type will not be 2, it will be 0, which then triggers the rest of the notarization, gatekeeper, and file quarantine checks, which unsurprisingly now blocks the application because it's from the internet, unsigned and non-notarized. Let's briefly wrap this up with some conclusions. First, a key takeaway, which I really want to reiterate. And that is, hopefully this illustrates that macOS still has a ton of shallow bugs. We talked about the fact that there was a very popular developer packaging script on GitHub that would inadvertently trigger flaw. So, you didn't have to do some crazy fuzzing or reverse engineering. If you actually just packaged up your application, your script with this, it would trigger this flaw and bypass all of Apple's anti-infection mechanisms. And we see this time and time again. Really, to me, illustrates that large components of macOS have never been audited, and there's a lot of very low-hanging fruit that still can be found. And these vulnerabilities, while shallow, are still very impactful, right? Being able to bypass all of Apple's anti-infection mechanisms, that's huge. And again, as a logic flaw, 100% reliably. We also in this talk talked about, the root cause analysis of the vulnerability, talked about how Apple and macOS does application classification and did so incorrectly. We showed that, unfortunately, attackers were abusing this flaw as a 0-day in the wild, but luckily we were able to provide some protections and detection strategies while Apple was awaiting a patch. And by reverse engineering their patch, it does seem that they comprehensively addressed this flaw. I also hope this talk inspired you or gave you some ideas, some tools, some techniques for you to go out and do your own splunking around the operating system, your own reverse engineering, malware analysis, or even, security tool development. And if you're interested in these topics, there's some more resources I briefly wanted to share. As I mentioned, I'm the author of The Art of Mac Malware. It is a book on analyzing Mac malware. It's free online. So if you want to learn more about Mac malware and how to become a proficient Mac malware analyst, check it out. Again, free, open source. I also organize a Mac security conference that's coming up at the end of September. A lot of really amazing speakers talking about Mac and iOS security topics. So if you're interested, check that out. Finally, I want to thank, first and foremost, you for attending my talk, either virtually or in person. I also want to thank the organizers of DEF CON for putting together this conference, especially in these trying times. And then finally, I want to thank the companies who support my research and my tools, allowing me to release open source tools and share my research with the world. So again, thank you so much for attending my talk. Stay safe and see you next time.
Hey, welcome to my talk, Hacking the Apple AirTags. My name is Thomas Roth. I'm a security researcher from Germany, and I also run a YouTube channel called Stack Smashing, where I talk about reverse engineering, hardware hacking, and all that kind of stuff. If you want to contact me, you can find me on Twitter @GidraNinja, and hope you enjoy this presentation. Now, before we start, let's quickly talk about what I will talk about in the next few minutes. So first off, all attacks that you will see are local attacks, and they all require hardware access. And so I will not show any drive-by exploits or anything that can be exploited over Bluetooth or so. Second of all, a lot of the info in this talk is based on reverse engineering, and so there might be minor mistakes. I maybe get something small wrong or so. And so the devil is always in the details, and as I don't have access to the source, everything is really based on reverse engineering and so on. And my real goal with this is to just have some fun with hardware hacking and explore a device in a fun way. Now, as always, this kind of work is not possible without a lot of other people, and so there are a couple of people that I want to thank. First off, Colin O'Flynn, who's one of the persons that nerd sniped me with the AirTags in the first place. Second of all, Leonard Wouters and Plonk, who I did a lot of reverse engineering with and who I did a lot of experiments with and so on. Jiska Klaassen, who gave me a lot of information on the Apple U1 chip and helped me a bit with some RT-Kit details. David Hulton, who provided very in-depth images of chips and provided delayering of the PCB and so on, and also limited results, without whom a lot of the work you're about to see would not be possible, because he found the actual vulnerability in the nRF52 last year. Now, before we jump in, let's talk about the AirTags itself. Now, the AirTag is a Bluetooth key finder, so really nothing too special, at least I thought so when I first saw it. But what's unique about the AirTag is that it contains ultra-wideband via the so-called U1 chip. Ultra-wideband is a technology that can allow, for example, iPhones that have ultra-wideband to very precisely locate the AirTag. And we're talking like centimeter precise, including direction finding and so on here. So this is something really neat. And ultra-wideband works in, like, I think the 5 to 6 gigahertz range. And so it's really high frequency and very difficult to analyze using cheap equipment. And so you really need very high-end SDRs and so on to analyze it. But now we have a very cheap device that contains this U1 chip that we can potentially use for research on ultra-wideband. The second cool feature is the Find My network. And so basically, when you use the Apple AirTag, any iPhone that goes into the Bluetooth range of it will report the location of your AirTag to Apple servers. And this is all done with privacy in mind. I don't really know too much about it, but it's a really cool feature because if you, let's say, lose your AirTag in France, you'll be able to locate it from Germany as long as any iPhone walks past. I also think it's funny because Wikipedia says that it's a key finder, but it doesn't actually attach to a key without separate accessories. Now, given all this, I was pretty uninterested in the AirTags, and I didn't buy any and so on, and I really had zero interest in them. That is until one morning I wake up and I get a message, hey, here are the flash contents of the AirTags. And attached to that message was a dump of the spy flash of the AirTags. Now, being a hardware hacker, I obviously at least had to peek inside of this dump. And so I ran hexdump on it, and I immediately saw this. And so you might see those strings on the right side here. And if you read them backwards, you might see that they basically spell out things such as firm root or NVRAM root, CRLG root, and so on and so forth. And if you've worked with Apple embedded devices, you might immediately recognize this as being the FTAP of an RTKit firmware. RTKit is the embedded operating system that Apple uses in a lot of very small devices such as the AirPods. And if you ever see such a firmware and you want to extract it, you can use a tool called FTAP dump, which makes it really, really easy. Now, knowing that this runs RTKit already made it slightly more interesting to me. But after digging into this for a bit, it turns out that this firmware is actually the U1 firmware. And so that's pretty interesting. Then scrolling further through the hexdump, I also discovered a couple of function names such as nrf_fstorage init, nrf fstorage write, nrf fstorage erase, and so on and so forth. And that is nrf52 code. Now, nrf52 is a very common microcontroller family that you can basically find in almost any key finder device. And so I'm very familiar with this chip. And so I thought that was kind of interesting. And so after realizing that maybe the AirTags are a good platform to, analyze the U1, play with U1 firmware, have a look at the NRF firmware and so on, I was nerd sniped and I knew that I need to buy an AirTag. So I went to the Apple store and I grabbed a couple of AirTags and I tried to open one up by, prying open the backside, and I immediately broke it. Like, I somehow ripped off this inductor because the AirTags are really, really sensitive when you try to open them. They have a very thin PCB, and if you nudge on the wrong side of it, you will destroy it. So if you try to open up an AirTag at home, always try to use these 3 points. It's basically where the battery compartment screws into the backside of the device, and there it's relatively safe to open up the AirTags. And so after destroying my first AirTag in literally the first minute that I unpacked it, I managed to open a second one, and this is basically what you see. You have a device with a ton of test points and so on, a couple of passives such as capacitors, the battery contacts, and the big coil in the middle, which is actually the speaker of the AirTag. And nothing really interesting except this small chip on the bottom right here. This is the accelerometer, and we will have some fun with that one later on. If you remove the PCB, which is really annoying because you basically have to pry it out because it's all glued very tightly into the AirTags, you will get to see this. And this is the interesting side, because this is where all the, integrated circuits, controllers, and so on are. Let's start with the biggest one. This big silver chip here is the Apple U1 chip, the ultra wideband chip. And if you look next to it, we have the nice antenna connector. Now, what's interesting about the U1 chip is that so far it was only available in very expensive devices such as the iPhone or the Apple Watch or so, not really in a price range where, you can buy 10, solder out the U1 and then experiment with it. But now with the AirTags, we have a U1 available for like 30 or 40 bucks. And so this is, I think, really going to be interesting, and I think we will see a lot of research with the U1 chip from the Apple AirTags. To the left of the U1 chip, we have the Spy Flash, and this is the Spy Flash that I got the dump to that nerd-sniped me towards the AirTags in the first place. To the left of the Spy Flash, we have the nRF52, a Cortex-M microcontroller. Now, this microcontroller is super common in any IoT device nowadays, and so it was clear that this chip would handle Bluetooth, most probably the iPhone communication, NFC, and it's also known to be vulnerable to a fault injection attack. And so basically this chip can be locked down, so you can prevent people from debugging it, but there's a known vulnerability there's a known vulnerability found by limited results that allows us to resurrect the debug interface using fault injection, as you will see in a bit. And so at this point in time, having the AirTag open and seeing the nRF52, the plan for me at least was clear. Find the test pads and pins to connect an SWD programmer to the device, unlock the chip using fault injection, and then hopefully gain access to the firmware to be able to analyze it and see how does the AirTag work. Is all the logic in the nRF52? Is all the logic maybe done in the U1 and the NRF just acts as kind of a modem or so? And so I was really curious at this point in time to see what is actually running on the nRF52. Now, normally when you open a new device, you have to probe all those pins and so on and figure out which one is actually the SWD interface, and you have to solder off components because the NRF, for example, doesn't really have any contacts you can probe and so on. But luckily for me, Colin O'Flynn already did all that work. And so on his Twitter, you can see that he created this nicely annotated version of the AirTag, and he also found out which test pads on the backside of the AirTag are the pads that we need to connect our debugger to. And he also already tried to program the debugger, and he also already tried to program the nRF52 and found out that indeed Apple had locked down the debugging interface. Now, this numbering scheme that Colin created kind of became standard in the AirTag hacking scene. And so if you are looking for some info on the AirTags and you see like some pin numbers or so somewhere, this is probably the numbering scheme that everyone is referencing to. And thanks to Colin, we know that pin 35 and 36 are the pins to which we can connect an SWD programmer such as a J-Link or a cheap ST-Link or so. And via those pins, we will be able to reprogram the AirTag. Now, as mentioned, the debugging interface on the AirTag is unfortunately locked down using a feature called AP Protect. And this one will basically lock down the control access point for debugging, and you can still erase the chip, which will re-enable debugging and you can program it, but then you lose the firmware. And so while we could, put our own firmware on it, at this point in time, it was much more interesting to dump the firmware than to put our own on it. And luckily, thanks to limited results, great work, we can just use fault injection to re-enable it. Now, what is fault injection? Basically, when you take the power supply to a chip and you drop the power for a very, very short amount of time, you can cause a kind of memory corruption in the chip. And sometimes this will allow you to skip over instructions. Sometimes it will allow you to corrupt memory reads and so on. And so it's kind of difficult to understand really what it does in the chip, because you can't really look into it while you drop the power for a couple of nanoseconds, but you can get a relatively stable attack using this kind of approach. And so the basic idea would be that during the start of the processor, at some point in time, the processor will check whether the debugging is disabled. And if so, it will skip the step of enabling the debug hardware. Now, if we manage to perform a fault injection attack at just this moment in time, we might be able to trick the chip so that the chip will enable the debug hardware because we skipped, for example, over the check instruction. Now, how do we do this on the nRF52? In general, most microcontrollers have an external power supply and then an internal power supply that is derived from that external supply. And so, for example, in the case of the nRF52, the chip normally runs at 1.8 volts. But then on the inside of the chip, those 1.8 volts are converted to different voltages for different peripherals. And so, for example, the CPU core might run at 0.9 volts, or Bluetooth might run at 1.2 volts. And the problem is, we only really want to attack the CPU core. We only want to attack the actual instruction. We don't really care about Bluetooth and so on. And we want to be careful to not disrupt other parts of the chip too much, because then it might happen that something else fails and resets the chip and so on. And so we want to target only the CPU core if possible. Now, these regulators tend to be quite noisy. And so to reduce noise, often the chip has an external connection for what's called a bypass capacitor. A bypass capacitor is a small capacitor that is directly connected to this internal voltage rail to stabilize the voltage towards the CPU core. And you might already notice, but one side of the capacitor gives us direct access to the voltage supply of the CPU core. Now, if we attach, for example, a switch towards ground to it, and we press that switch, we will create a short circuit that will disable the regulator. We basically suck all power out of the regulator, and by that we can interrupt the power supply towards the CPU core. Then if we open the switch again, we re-enable power. Now, obviously, with a manual switch, we can't get the precision and the timing that we require to hit just the right instruction. If we, however, connect a MOSFET to it, which is just an electronic switch basically, we can digitally control the CPU core power supply. And now we can use, something like an FPGA to control the power supply and time it very precisely. Now, I like to go cheap on these kinds of attacks and always show just how easy, for example, fault injection is. And so I decided to use a Raspberry Pi Pico to perform this glitching attack. And so basically I connected the MOSFET to a Raspberry Pi Pico, and now if the Raspberry Pi Pico enables one of its IOs, it will interrupt the power supply to the CPU core. And then if you turn it off again, the CPU core will start again. And so if we hook this up to the attack, we basically first need to find that bypass capacitor. Now, Apple was nice enough to put that capacitor on the back side, and so the easily accessible side of the AirTag. And even better, they even put a test pad right on that core power supply pin. And so we can just solder on a cable there, connect our MOSFET to it, and we are almost ready to go. Now, fault injection in most cases is not something that you just try once and are successful, but in most cases you want to try a ton of times and eventually you are successful. And because each attempt is really short, like let's say 100 milliseconds, we can try 10 times per second. And so even though we try 100 times or 1,000 times, we still get our desired results pretty quickly. Now, to be able to restart the AirTag and to also get a signal when the AirTag is actually booted, we also want to connect the nRF52 power supply towards the Pico. Because basically the AirTag runs at 3 volts from a battery, and it takes a couple of milliseconds for the power supply to reach the nRF52. And so we want to make sure that we get a signal on our Raspberry Pi Pico once the chip starts booting so that we can time our fault injection attack just right. To do this, we basically use a level shifter to convert the 1.8 volts from the nRF52 to the 3.3 volts that the Raspberry Pi Pico expects on input. And then all we have to do now is power up the AirTag. And you can do that by just connecting an I/O directly to the battery contacts of the AirTag. And so what we can do now is we can turn on the AirTag from the Raspberry Pi Pico. Then we wait until the power supply to the nRF52 is enabled, which is basically the point in time at which the nRF52 boots. And then we can perform our fault injection attack using the MOSFET connected to an I/O. Now all we need to do is also connect an SWD programmer that we will then use to check if our attack was successful. And so basically we start by just turning everything off. Then we turn on the power supply towards the nRF52. We wait for the signal from the nRF52 power supply, and then we wait a short amount of time, and then we enable the MOSFET, which will drop the CPU core power for a very short amount of time, and then we re-enable it. And then we use our SWD programmer to check whether we are successful. Now, this sounds like a lot of complexity and a lot of work, but it's really, really easy. And so, for example, the code on the Raspberry Pi Pico is just these couple of lines. Basically, we power cycle the target and we wait for the NRF power to boot up. Then we wait for a configurable amount of time, and then we glitch for a configurable amount of time. And if you set this up on a real AirTag, it will look something like this. And so we have our AirTag, in this case, in kind of a breakout state to make life a bit easier. Then we have a debugger, which is basically the programmer that we use to check whether our glitch was successful. And then we have this breakout board that I designed, which is really just a Raspberry Pi Pico with a couple of level shifters and so on to make life easier, and also with the glitcher on board. Now, as you can imagine, the boot of the nRF52 takes quite a long time, and so finding just the right spot in time where we drop the power to attack it is pretty difficult. Luckily for us, limited results documented pretty well with the power trace at which point in time of the boot of the chip we need to glitch. And so in his blog post that you should check out on limitedresults.com, he precisely describes at which point in time you need to drop the power for a very short amount of time to re-enable the debugging interface. And after setting this all up and using a glitch width that I knew is successful from the past, we are ready to go. Now, if we look at this on oscilloscope, you can see that our glitch is not really precise. This is because the code that I'm using to glitch it is very imprecise. But as it turns out, this is enough. You will get lucky eventually, just because, you know, the likelihood is that if you try often enough, you will hit the right point in time. To control the glitcher, I wrote a simple Jupyter script that basically just sends the delay and tries a range of delays, tries a range of pulse width basically for the glitch, and then just checks whether JTAG is enabled. And so I let this run for a bit, and after like a couple of minutes, I got lucky and I got this success. And success means that basically JTAG was re-enabled. The test JTAG functions in the test JTAG function in the Jupyter notebook tests whether it can connect via SWD to the chip, and in this case that was successful. And suddenly on my hard drive I found this. My script automatically dumped all the interesting areas of the chip, and so we had the flash dump, the BP ROT ranges, FICR, UICR, and so on, all the interesting ranges that are in a chip. And so I started analyzing the AirTag firmware. I started by just running strings on the firmware, and I immediately recognized these strings here. This is an indication that they actually run Core Crypto, which is Apple's crypto library, on the AirTags. And the next thing that jumped to my eye was this URL, found.apple.com/AirTag. This is the URL that you get when you NFC scan an AirTag. It will lead you to a URL with like the PID and so on encoded in the URL. Now, I was really curious to see whether the firmware had any additional validations that I didn't know about. And so I tried to modify the URL in a hex editor and reflash the firmware to the AirTag. And then I got this. And so what do you do when you can change the URL of something to whatever you like? Obviously, you try to rickroll people with an AirTag. Now you might wonder, well, why would you go through all of that effort to rickroll people? And I had a ton of YouTube comments ask exactly that question. Hey, why aren't you just using an NFC sticker and so on? But the goal with this was really just to see whether the firmware has any additional verification methods. And this was the easiest way to check whether we can just modify something, because it's very visual. You just tap it with your iPhone and you know whether you are successful. But continuing analysis of the strings output, I found this line here. And I recognized these letters because in the iPhone, this is exactly the serial number that I saw in the Find My application for this AirTag. And so it turns out that we can also freely edit the serial number of the AirTag. And so, for example, mine is now stack smashing. And this is pretty interesting because I personally expected the configuration to be in the U1 or on the SPY flash or so, but apparently all the configuration details of the AirTag are stored in the nRF52 internal flash. And that brought up a pretty interesting question, because after pairing, for example, you can also see your censored email address and so on, all in the AirTag firmware, basically. And this brought up the question to Leonard and me whether we can actually clone an AirTag. And so our idea was that I would dump a configured AirTag, send the flash dump over to Leonard, he would flash his AirTag, and we would check whether, my AirTag would be discovered in Belgium, where Leonard lives. And so we set this all up. I had my AirTag nicely set up at my home place. I dumped the AirTag, I removed the battery, I sent the firmware over to Leonard, and what do you know, a couple of minutes later, my AirTag was suddenly in Belgium. And so it somehow, in a couple of minutes, traveled a couple of 100 kilometers. And so it works. We can clone an AirTag. All data that is required for cloning an AirTag is in the nRF52 flash. And this is pretty interesting because this also means that if you, for example, find an AirTag or steal an AirTag, you can actually reset it and set it up with a new serial number, bypassing the lost function and so on and so forth. And neither the SPY flash nor the U1 seem to be really involved in the pairing of the AirTag. And so that was pretty interesting because we all were pretty sure that Apple would do some crazy stuff with the U1 or so to make life of cloning and stealing and so on a bit harder. And I'm curious what this will mean for example, bikes that have the Find My technology integrated. Now, with this information, we also started comparing our two dumps. And so we basically started comparing what is different between different AirTags and what changes with the pairing. And for example, here in the hex dump, you can see my email address, the censored version that is shown when you find the tag, and so on. And overall, the information that is part of the pairing is relatively low, and you still have a bit of room in the firmware to, for example, integrate your own custom payload into the AirTag. And one thing that got a lot of buzz surrounding the AirTags was its privacy protections. A lot of people were very afraid about getting tracked by an AirTag. Now, while I get the idea of being tracked, I personally think that the AirTag is a terrible tracking device. It doesn't have a microphone, well, a real microphone. It doesn't have GPS. It doesn't have GSM. The only thing that you have is Bluetooth and the location of an iPhone that walks by. And even there are some limitations. And I mean, if you go onto Alibaba or so, you can get a decent tracker with like all of these features like GPS, GSM, microphone, and so on for $20. So it's even cheaper than an AirTag. And it's not like an AirTag is particularly small or particularly well to hide. And so what I'm about to show is, I don't think it's really an issue because I don't think the AirTags are a great tracking device. But basically, the AirTag has a couple of privacy protections to prevent people from just, putting an AirTag in your backpack and being able to track you. If you have an iPhone and an AirTag moves with you for an extended period of time, your iPhone will give you an alert. And so you will get a pop-up saying, hey, an AirTag has been following you, and then you can get that AirTag to play a sound. And from my research, this seems to be based on the ID that is broadcasted by the AirTag that changes regularly. Now, knowing that this ID is generated in the NRF52 code, and knowing that I can, modify the original firmware, I wondered, what if we make our AirTag have multiple identities? And so basically, instead of having, one identity on my AirTag that would change its ID every, 24 hours, what if I have a lot of identities and I would basically cycle through them relatively often, and the iPhone would think every time that this is a different AirTag, and it wouldn't detect that the AirTag is following me, basically. And so to implement this, I needed to do some further firmware modifications. But for that, we first had to actually analyze the firmware. And so I started loading the firmware into Ghidra and found that it's really standard NRF52 code. It uses the normal NRF52 SDK functions, and so that is pretty cool because it allows you to create signatures from the original NRF52 SDK and then apply them to the AirTag firmware, making your life much easier, and you don't have to reverse engineer everything. Also, what was interesting was that no runtime mitigations or hardening was found. And so, for example, there are no stack canaries and so on. And so if you find something like a buffer overflow, it's most probably relatively easy to exploit. But overall, the firmware was relatively straightforward to reverse engineer and so on. And so the idea of building these privacy protection bypasses was relatively easy. And unfortunately, and so after a couple of experiments, I had my custom firmware ready. It did not trigger any privacy warnings in our testing on iOS 14.5. Tested this with a couple of iPhones, with a couple of people walking around. But it also has very limited usability because to manage those identities is kind of difficult because, the Find My app only supports 16 AirTags at once and so on and so forth. And I also decided to not publish the details on this firmware yet until this is fixed one way or the other. And the reason for that is that after publishing my first YouTube video about the attacks on the AirTag, I got a lot of emails like this asking me whether it's possible to bypass the warnings, and a lot of people actually offered me money to bypass those protections. And so given that there seems to, even though I think the AirTag is not a great tracker, I don't want to be the person that enables people to track others using the AirTag. But another thing that a lot of people wanted was changing the sound of the AirTag that the AirTag makes when you search for it. Now, sound reverse engineering is kind of fun because normally when you reverse engineer something in a firmware, you need to use, IDA Pro, Ghidra, Binary Ninja, or Radar or so. But for audio, it's really nice to just load it into Audacity because in most cases, the firmware will have raw sound samples contained in it. And if you look into the Audacity menu, you can find that it has this point called Import Raw Data. And there you can just experiment with different encodings, byte orders, channels, sample rates, and so on. And eventually, you might see something like this. And if you look at the center here, that looks a lot like valid audio. And indeed, if we play it back, just this part in the middle, you can see that this sounds a lot like the noises that the AirTag makes, just a bit shuffled around and so on. And it turns out that the audio player is kind of this small sample player where you have multiple samples that create one sound and so on. It was kind of a surprising amount of work to reverse engineer it and get it working nicely. But after a while, I had this suite setup ready. And by the way, at this point, again, thank you to Colin O'Flynn and Leonard, who did a ton of reverse engineering on this. And again, without whom this would not have been possible. And so this is the regular sound that the AirTag makes. And here is my AirTag. Now, you might be surprised by the sudden stop of the sound here. This is not just because I clicked stop, but also because the AirTag just crashes at this point in time. I'm not entirely sure why, but probably the reverse engineering of the sampler was not yet good enough. But hey, we now have an Apple-branded Rickrolling device that you can put in somebody's pocket and Rickroll them. And so I hope to release some tools for modifying the firmware to do that soonish. Now, another question that a lot of people had towards me is, can we use the AirTag as a bug? And the main idea of a lot of people was that, hey, it has a speaker, right? And a speaker is always also a microphone. Well, on the AirTag, unfortunately, not unfortunately, but luckily basically, between the microcontroller and the actual speaker, there's an amplifier. And that amplifier has no way to provide feedback to the CPU. And so we can't really measure anything that goes on in the speaker. However, what we do have is another tiny device over here, which seems to be a Bosch accelerometer. And an accelerometer can measure vibrations. And I mean, what is sound if not just, vibrations? And this is something that is very well known to be possible with accelerometers, but I had never done it. And so I thought this would be a fun experiment to try to use the accelerometer as a microphone on the AirTags. Now, unfortunately, I could not really get a high-speed signal, like not, I don't know, a 12 kilohertz accelerometer signal from the accelerometer, and it's also a custom part. Like a lot of websites claim that it's a BMA 280, but I don't think it's a 100% match. So for example, the footprint is different and so on. It seems to be a custom chip, which wouldn't be the first time that Bosch has created a custom accelerometer for Apple. Now, the problem is the accelerometer is not really sensitive to sound. And so even if you yell against it, you will only get very slight signals. And so I built a very specialized audio chamber for audio testing the AirTag. And so this device, which is totally not a regular Pringles can, is my very sophisticated audio chamber for testing the AirTag and using it as a microphone. And so you basically put the AirTag on the bottom of the chamber, because that's where especially the deep vibrations will be very, very significant. And that's needed because we have such a low sample rate that we only can get the low end of the spectrum, basically. And after a couple of tries, a ton of post-processing on the signal, this is the sound that I got out of the AirTags. I don't know if you want to call that a success. So I personally think that the Apple AirTags are not really a great microphone, but I can tell you that I had a ton of fun trying to get this working and trying to use the AirTags and its accelerometer as a mic. Now, last but not least, let's talk about the U1. Now, as mentioned, the U1 so far was only available on higher-end devices such as the Apple Watch and the iPhone. But now it's available for a really cheap price, or well, cheapish price. And it seems that during pairing, the firmware is transferred from the iPhone towards the SPI flash of the AirTag, and then the U1 firmware is loaded on demand towards it. And what's really cool on the AirTag is that you can downgrade it. We have full code execution on the AirTag. You don't need a jailbreak. You don't need to have, an up-to-date iPhone exploit. No matter what updates are coming to the AirTag, Because the fault injection attack is unfixable, we will always be able to inspect what's going on with the U1 on the AirTag. And we can create breakout boards for it and so on. And I'm really excited to finally have cheap U1 and ultra-wideband research for the Apple ultra-wideband ecosystem. And if you want to learn more about the U1, check out Yiskas and Alexander Heinrich's DEF CON talk this year, who are talking about the U1. Now, we also were able to create a full diagram of the Apple AirTag. David Halton polished each layer of the AirTag PCBs, and then we reassembled it in an image processing software, and now we have each layer of the PCB, and so this makes it really easy to trace, for example, the connections towards the U1 and so on. It makes life much easier when you just want to, sniff a certain line and so on and so forth. If you want to learn more about all of these things, the glitcher is open source on my GitHub. The reverse engineering details from Colin are published on his GitHub, and I also have a repository with all the hardware pictures and the high resolution PCB pictures that allow you to very easily see what communicates with what and how does everything work. I hope you enjoyed this presentation, and if you have any questions or comments, please don't hesitate to contact me on Twitter or via email or whatever, and hope you enjoyed DEF CON. Thank you.
Hey, let me adjust the volume here. So let me turn on the light. There we go. So basically, we had a ton of more videos than that, but just due to the interest of time and for the stream, I think 3 full-on DEF CON talks about Apple stuff is enough. We'll probably be doing more Apple things later this year or early next year, so we'll have more uses, because I've been wanting to make a sequel to Egg Freckles. That was one of my favorite meetup/live streams we've ever done in the group. But anyhow, that's going to be it for Dub, as the weird cult of Mac calls it, or the Worldwide Developers Conference, WWDC in 2022. So if you're on Twitch, stay tuned. We're going to go raid a stream, and I might be on stream tomorrow because I really want to bring back Patch Tuesday. But worst comes to worst, there should be a bunch of streams we're going to be announcing all weekend. And worst comes to worst, also on Saturday is Crypto Barons, where we'll be finally looking at cryptocurrency and blockchain games because it's Summer Game Fest. So stay tuned for all of that. Stay tuned for all the announcements. If today was your birthday, happy birthday. If you like the content you see, please sure to follow us on Twitch, D Live, YouTube, all the stuff that we subscribe for. Sorry. If you want to check us out, our website is still on the fritz, so I'm going to share you the Medium blog. We're also on multiple forms of social media, with our big best ones being Twitter at DEFCON201NJ or Instagram at just DEFCON201, but here is the entire master list for that. If you want to chat with us until we get our IC sorted out, here's our Discord. We usually do hashtag CTF because we're doing CTFs. We're going to be doing more CTFs in the summer and throughout the rest of the year, but there's a link for that. I hope to see you next time. Again, please like, share, and subscribe if you want to get alerts for stuff. Hack the Planet, Dirty Jersey represents, and remember that, things are basically crazy for me. Things are going to be crazy for me, but things are okay. It's going to be crazy for DCG 201 in general, and we still have a lot of stuff we want to do, and I'm just looking forward to, not only having in-person meetings again with a ton of people and amazing speakers and cool projects and hanging out with all of you folks, but just all the interesting, crazy stuff that we've been wanting to do for years that will probably happen summer to fall this year and definitely be happening next year. Peace, you guys. Say hi to the person we rated and enjoy the music.